Oh, is it on now? Cool. Hello, everyone. Thanks for coming, and it's my honor to be here. Thanks for having me. I'm Andy. I'm an engineer from QuantStamp, and at QuantStamp, we are like the security company. So today we'll be talking about like how we at QuantStamp help secure like the past, present, and future, and just share some stories, interesting stories we had from our experience. So who are we? We are a security company. We try to secure the future of Web3. And as a security company, we are very lucky. We can get involved with different kind of clients. A lot of them are top projects within this industry. And we are also a global team. So we work remotely. Like all of our coworkers are from different places around the world. I think it's probably the same for a lot of like blockchain companies. And last, we're probably one of the earliest smart contract auditing firms, and we're also trying to continuously improving ourselves. And that's what we're trying to share today. So as the old wisdom said, the best defense is a good offense. As a product developer or as a product or as a protocol company, like the way you want to get your user is you must make sure your user can trust your product or your protocols. So you need to make sure your security is of the highest standard, so like user would be able to be comfortable interacting with your protocol or your product. And to do that, that's what we're trying to serve. We provide audit services. That's our core service. So we usually do audit for smart contracts. It includes like, for instance, like NFT, DeFi, and a lot of things. And today is an Ethereum conference, so a lot of them would be in Solidity. Aside from smart contract, we also help like auditing things like the layer 1 blockchain itself. For instance, these are some of the audit we did for the ETH.0 clients. And also, we also help like wallet or like key management things as well. Aside from that, we not only do audit for like Ethereum, we also help like Solana, like we did like their system contract audits, and also a lot of layer 1 or layer 2s. Like we also help Boba to do their optimistic rob audit as well. And we also usually treat our client as a friend. As a friend, we help. So we try to increase our impact, not just from auditing. There are times like client would come to us that they are not sure what's the best way to implement things. And that's how we come to help, because we were able to look at other protocols or how other people do. So we can, for instance, help them figure out like what's the best algorithm to do. So there's my personal experience. Where one day we have a client, they come to us, they're trying to write a staking smart contract. So as people probably know what staking usually is, like you provide your liquidity, and then whenever there's a reward, like you get certain reward depending on your portions of liquidity. And at that time, the client, when they come to us, we're immediately like, oh, this looks a bit weird, because the way they're sharing the reward was like they run a for loop. They just run through all the stakers that's registered, and they give them the reward. So it's like immediately we're like, this would have some gas issue. And that's the time we're helping them. We're trying to help them like, so we see a lot of other DeFis, how they use it's like if people is developing in DeFi, they know it's usually using like reward per share algorithm. And that's what we share with them. We tell them like, hey, actually, here's a blog telling how you do this algorithm. And there's even sample codes. And the client eventually updated their algorithm, and then we were able to finish our audit. Another interesting story is from like we have a optimistic rob clients. So not sure if you're familiar with layer 2 or not, but whenever you're bridging things from layer 1 to layer 2 or layer 2 to layer 1, you have like different kind of messages that have to be relayed from either from layer 1 to layer 2 or vice versa. However, usually the protocol team would help to do that, but it is super expensive. As you can imagine, like all the transactions, I mean, they're layer 2, but sometimes if they want to bridge things back to layer 1, those messages or those transactions, they're helping you to relay back to layer 1, and they have to pay the gas fee for that. So we are discussing like how we can solve this, and we also try to provide some potential solutions, because I think currently there is no perfect answer for this yet. So that's another interesting stories we had from we are helping out our like friends and clients. So as a security firm, we're very lucky. We have able to like look at so many different kind of things, and we're able to get enough. And also we have to keep ourselves alerted with different kind of hack or exploit during the period. So we are able to learn a lot of things from the past. So one of the really like epic things we participated before was the MakerDAO Black Thursday. Not sure if anyone here was still in this industry in that time. It was a few years ago. It was like I think 3 years ago, 2020 March. So what happened at that day was like there was a time like I think it was a bear market, but it started to get up, and then all of a sudden Ethereum in the day like dropped around like 40% in the price, and that itself it doesn't break things yet. But then the problem was like, now I think nowadays all the gas are super expensive if you're interacting with like Ethereum right now. But during that past years, the gas fee was actually pretty cheap. Like 5 GWay was like the normal, and 10 GWay is already like, oh, that's expensive. I think nowadays if you're interacting, it's like, oh, 10, that's freaking cheap. So it was the opposite situation compared to now. So what happened that there was the price drop so fast on the market. So everybody is trying to either like run away from exchange, or they're trying to do whatever things they think is better for them to hedge the risk. So there's a lot of transaction happening on the Ethereum at that single day. So what happens, like the gas price suddenly goes up from a very low level. And then when the price goes up, it starts to break things that's off-chain, which was like people wasn't imagining. So the first thing that started to have an issue was their oracles. And Oracle was kind of like the backbone of the infrastructure of DeFi, if people would know. So because you need the Oracle to provide the price on chain, otherwise the smart contract on chain wouldn't know how to get those things. So what happened at that time was like the gas price goes so far, the Oracle wasn't able to send their transactions to the chain to update their price. So the price keep saying like the old level, and then all of a sudden when the Oracle transactions eventually get in, the price drops so fast, it starts to break all the healthy threshold for the MakerDAO. Oh, by the way, so how MakerDAO work is like they have a lot of collaterals, and they use collaterals to mint their DAI. And so when it drops their healthy threshold, those collaterals would be sent into an auction for sale. It feels like you're lacking money. You need more money to cover your DAI. And so that's how it started, because Oracle price couldn't get in, and then when they get in, boom, like a lot of things just start to break. And once those auctions go into there's another thing start to break the same way because of the gas price. So MakerDAO did provide some software for the users to run, and then so they can automatically beat those auctions to buy those collaterals when they're liquidated. But the problem is, like those software also have the gas price issue. Let's set a gas limit that's not high enough for them to get through these kind of situations. So those bidding transactions wouldn't pass through as well during the auctions. And until one attacker realized this, and so the only thing he did is he just increased his gas price, and he do a very like weird bid. It's just like he's just buying ETH with 0 DAI. And it started to went through. And a few attackers also realized this, and then all of them start to attack in this way, because all the other people who's using the original MakerDAO software, they just couldn't went through their bid. So only those bidders just buying with 0 DAI went through, and all the Ethereum from the MakerDAO collateral just been kind of stolen, but although they're just following the protocol. So that was what happened during the MakerDAO Black Thursday. And it was around like, I think 8 million of loss for the protocol itself. It doesn't look that bad compared to a lot of current hacks, but it was a very huge one during that period of time. Specifically, like it was before the DeFi summer or just around the DeFi summer. So to solve this, eventually there's a community group called the DAI Backstop Syndicate. They're trying to sort of, come here and try to resolve this problem. So they come up with a solution, which is they mint more Maker tokens, like their governance token. So they mint their governance token and to do auction for their governance token to try to compensate those collaterals. However, just in case if that doesn't work, because they set a very huge limit, I think it was like 50K. Unless you're buying 50K of those tokens, then you can't really participate. So in case those wouldn't work out, to enable like the retail users to participate in this kind of auctions, there's a group called Syndicate, and they provide a syndicate contract. And so during that time, what Constant helped was like, they had this, we joined this group of community people, and then they have this contract, and we immediately audited it. So I think the hack was happening on the 24th, if I remember correctly, and then this contract was audited just 1 week, within a week. So it was a very fast reaction. I mean, the things still happen. The hack is still, like, loss is lost, but I think all the other process, especially this is from a community, it went through, like, pretty fast. Yeah. So that was the first one we're going to talk about. And the second one, another historical event we used to help was like the voltage finance. So we didn't really help directly on the voltage finance hack. So this hack, it was a compound-related hack. So I think if you have ever been developing Solidity contract, you would know about reentrancy issues. So this is a hack due to reentrancy. But the problem and how they did is like, this is a voltage finance, is a fork of the compound. But it was fine in compound because the compound never interact with, I would say, like weird ERC20 tokens. So there are some kind of ERC, I mean, they're not really ERC20, they are following ERC, probably another protocol. But then they have a hookback functions. So whenever they're receiving the tokens or they're sending the tokens. So this allows, those kind of protocols allows the tokens to be reentrant to other protocols. But then in the compound, they have a governance process. So they do the due diligence for all the integrated tokens to put on their pools, where a lot of fork wouldn't do the same. They would probably fork the code and then they just put it and then just start to run it. So that was the main issue here. So this team, they forked the compound code, but they didn't follow, or they might not know, like they actually have other security operational process to help mitigate some of their risk. So without knowing that, they come up with this kind of hack because they allows integration with those kind of more unstandard tokens. And so in this case, what we helped was like, we had a lot of our clients that's working on compound fork as well. So when we realized this, we immediately, I think, well, during that period, there are more than this. I think there are another few hacks with the same issue. So we immediately alerted like the people or the teams where we know they're using the compound fork as well. And we helped like at least 2 of them to avoid this problem from happening on their protocol. Although another probably 13 was fine, yeah. So that was how we sort of help out on our past clients and how some of the past exploit, and we try to learn from them. However, we're living in the prison world, and we have to, as a security firm, we have to continuously improve ourselves to be able to catch up with the newest things and to catch up with like the newest hack, because they always come up with new ways to to attack. So to do this, within our company, we're doing a monthly hack roundup. So we have engineers every month. We actually will try to look at what happened during the past months, how many dollars were lost, and we try to understand and learn like those things, how those hack happens and how can we prevent it from happening again. So one very interesting one is like D-Force. It is again reentrancy attack. But this time a little different. It's a view reentrancy attack. So a typical reentrancy attack, you have a state change, and before you finish in all the transactions, you go back to the function again. That's how you start the attack. But in here, the view reentrancy attack, usually a view function in Solidity, you won't be able to mutate the state. So what it does is it's actually calling another function that would change the result of the view function. And then when you're integrating with this protocol, if you're calling the view function, you'll get a wrong value, and that's how they attack it. And usually it happens for like for those functions that's providing the price for liquidity pool tokens. So for instance, if you're integrating with Curve and you want to know like how the Curve LP tokens price would be, you might call one of their functions to get the price of LP token. But these functions could be gamed in the reentrancy way because, as you can imagine, how you would calculate the LP price, it will be like you have a pool with 2 tokens, so you'll be like how many tokens of token A is in the pool and how many tokens of token B is in the pool, and times their market price divided by the total balance or total supply of your LP tokens. That's how you will calculate like how each LP token would have its own value or what the price it is. And during the reentrancy, for instance, if you are, let's say, withdrawing the liquidity, then when you're withdrawing liquidity first, you will burn the LP token because you're sending the LP token back to trying to get your original token from the pool. So you will burn the LP token. This part is probably fine. It's probably hard to reentrance. But then when they're sending back the original tokens, then this part could potentially trigger the reentrancy. When they send back, they can trigger the reentrancy. Then in this part, you have 3 variables. One is like the token A, token B, and the LP token. The token B is still not changed yet. So you will have a round formula in here if it's reentrance. And you can reentrance the integrated protocol where it would get a round value. So you will be calculating the round value of your LP token, then everything could be wrong, depending on how you integrate it with it. So that's one very interesting attack that we've seen. Although like this specific vulnerability has probably been announced like around a year on Curve, but depending on the protocol, they might not be aware of it. Another very interesting takeaway we get from this kind of monthly hack roundup is we realize sometimes the hacker or the attacker might not have an exit plan. So they are very smart. They come up with a plan to attack you, but they didn't come up with a plan how do they withdraw those money out to real life. So I think like one time we see a hack and the hacker are actually using their own ENS that's probably linked to their Twitter account. So I think after 2 or 3 days, like the guy was arrested after that, just because like he didn't really do too much effort on that part. And also like a lot of tokens, like for instance like USDT, like they can immediately blacklist your address if you didn't try to mix it up to another address fast enough. So that's another interesting takeaway we get from our monthly hack roundup. Besides of that, we also have restart retreat, which in Japanese we kind of call it like shugyo. So we try to lock ourselves for a week in probably, I mean, in real life, it's been hotel. It wouldn't really be in the temple, but we try to lock ourselves in a hotel. And for that way, we were just discussing about like, what are some, for instance, like what some potential hacks for some kind of new ecosystems or for new kinds of architectures, what are some of the weakness? And this, or sometimes we just discuss like, what are some new tools? So for instance, I think for the next one, we'll probably be discussing about how we can use ChatGPT to do our audit, potentially. So we gave it generated a lot of our talks or our papers from this. And so for instance, like we had last 2 years, we discussed about like what kind of potential hacks could be happening on bridges. Because actually a lot of bridges nowadays are still pretty centralized. Not sure if people are aware of this. And even not centralized, like they're still like how bridge handles reorg. Usually they didn't really handle it very well. So we realized this after we do the research. Another thing last year we did was like we're reviewing all the rollup systems. And usually people, when they come to rollup, they'll think, oh, it's a layer 2, it should be very decentralized. But then because of their sequencer are usually still nowadays, I think it's improving, but it's still centralized sequencer. And they don't have a very decentralized way for them to exit from the layer 2 if they indeed have some issue for the sequencer. So that was another research we were trying to do, and then we also have a short paper for that as well. So these are the things we do try to keep ourselves up to date. aside from that, we also try, usually when the people come to us, you feel like we are third party. We are a bit farther, a distant away from you guys. But there are times we try to actually be more, like integrated to your your protocols. For instance, like in the Clayton, which is a blockchain itself. Not sure if people know that. I think it's from Korea, so it's probably more popular there. And we actually try to stake and try to join their governance. So we try to be part of them. And we also run our own validation nodes for them to secure the network. And this helps us as well, though, so we learn more knowledge. And that's how we can get more deals. And get more deals, we learn more knowledge, and we can use it as a good cycle to improve ourselves. So as our missions is to secure the future of Web3. So we not only try to do those things, we also help train new talents. Because in the future, it will be a new generation that's working on the blockchain space, or even the AI with blockchain space, perhaps. So we have engineering helping this. For instance, like before we work with like a DeFi talent, I think it's a program that's trying to train like new engineers working on DeFi platforms. So we have like a biweekly call with them, trying to share of some of our knowledge and try to share like some of potential career paths with them. We also have an engineer currently teaching in like a university in Taiwan. So he have a I'm not sure it's a blockchain or DeFi course, but he have a course there. It's a full semester course, and I look at their agenda. It's pretty deep. I think it's from 101 blockchain 101 to all the way to like very, very complex DeFi contracts. Yeah. So that's how we're trying to help in this industry. And so far our product or our service has been helping to secure before launch. That's why we do audit. So we help to ensure your quality before you're deploying your contract. Or although like a lot of clients deploy their contract and then after a while they come to us, that's another story. But usually our security, we usually help before you deploy. But we are also trying to see how can we actually continuously helping our people to help secure them further on, because it's an ongoing game. It's not things that you finish after deployment. So we have a subsidiary called TrendProof, and they're trying to provide sort of like a guarantee, like an Apple Care. So whenever you have an audit and we're happy with your quality, then we can potentially give you this kind of guarantee, which in the future, if some exploit does happen and we didn't catch it during our audit, then we will be able to refund you into a certain degree. And also we will provide a continuous monitoring service. That's where we would be able to alert them like, hey, I think this is weird. You probably want to take action to pause your contract or to do certain actions within probably like an hour. To try to mitigate the loss of your exploit. So yeah, so that's what we're trying to do in the future and continuously improving this. So that's pretty much it. Thank you, everyone. Any questions?
What is the name of the blockchain course?
Oh, it was called DeFi Talent, but I think it was a bit weird, like a bit years ago. Yeah, we had another course, but that's on like the university inside the university, so it's probably not online. Yeah.
So it's possible to use ChatGPT to audit contract?
I think not yet. It will provide, I tried, like it will provide certain insight, but it's still a lot. First, like it has a lot of false positive, and it sometimes doesn't really fully understand it as well. So I wouldn't say yes right now, but given the current status, I think, yeah, probably after years, it will. And we need to figure out how we're gonna survive.
What, in your mind, is the most ingenious hack you've seen?
That's a good question. The most ingenious one. Well, so one of the recent one, it's not really ingenious. I think it's not like they use certain things that's super brilliant, but one hack I used to see, like they just find one line of bug. I mean, a lot of hack is like that actually. So I found that that's very interesting because they have to spend so many effort on actually looking their contracts, and they don't even know which one would have issues, right? So I probably don't want to name the exploit itself, but then I used to see one, and then it's really just one issue that's because of the mapping. So when you're mapping, then usually you wouldn't map like a zero key, right? You wouldn't have like a dictionary zero equals blah, blah, blah. But somehow like during the previous deployment, they accidentally deploy the value to that mapping slot. Although in the later deployment, they never used that. So people forgot about it. But then the hacker realized that and then used that as a hack to get a fee. Yeah, so that one was very interesting. And then even worse was like everybody can copy the hack. So that at that time, like there's a transaction there, and then people just copy paste their transaction, probably change their address, and then just boom, and the next hack happened, and then boom, boom, boom. So it's originally it was one attacker, and then it becomes a public attack on the world. Yeah. Cool. I guess if no more questions, then that's it. Thanks everyone. Oh, if
Yeah, before you all leave, because you came, we do have some swag, and it's like super, super scarce, like Bitcoin scarce, like swag. So we have like 10 plushies, we have 8 t-shirts, sorry, and some tote bags. Y'all can come and pick something and take whatever is left. But yeah, sorry if we can't give you what you want, but it is what it is. So.
Can I get this one, sir?
You can, yeah, you can take. Can I get one? Yeah. Plushie? Plushie? Of course. Who wants a plushie? Very rare dinosaur.
Yeah. Can I get one?
Rare quant-stamp dinosaur.
Awesome.
Dinosaur? Yeah, of course. Take a t-shirt. The t-shirts are really good, by the way. Like, they're like legit, like, nice t-shirts. You want a t-shirt?
Yeah. L size.
Sorry, L size? Nobody wants a tote bag? This is actually like a really nice tote bag as well. No?
Can I grab
No?
it?
You want a bag? Yeah. Pick that.
Can I grab this?
You can have, yeah. Of course. Of course. You can have. You can certainly have. You want a bag? Yeah, these bags are actually really good. Nobody else? Nobody else? We still have t-shirts. Quant-stamp t-shirts. They're very large, though. You can have a very large t-shirt. Actually, maybe this one. Small. Medium.
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 I want medium.
Okay. Anybody else?
Yeah,
No?
gonna
No takers?
switch middle.
You're waiting for us to leave. Okay.
Can I get one of those dinosaurs?
You.
And look, my friend.
There you go.
Perfect. Thank you, sir.
All right. Nobody wants t-shirts or tote bags? I can't.
This turned off.
Come on. Anybody? No? Extra large?
Hi guys, thanks for coming. I'm Kirill. I'm one of the core developers at the Bob and ETHGlobal project ecosystem. And we are building a next generation stablecoin with optional privacy. So we're gonna talk about that. So we believe at ETHGlobal that financial privacy is, first of all, of course, very important for everyone use cases, not only in crypto, but in Web2 world. And as in Web2 world is really a norm for people to think that their financial privacy is somehow preserved within banks and other institutions. In crypto, it usually becomes a big problem since the crypto blockchains and are basically public ledgers, and all information about public transactions are freely available for everyone on chain to see. And when it comes to sensitive financial information, so there is no really a simple mechanism for achieving privacy in these financial activities within everyday usage of stablecoins. So at ETHGlobal, we are trying to fix this problem by introducing this optional privacy for a stablecoin. So we are basically right now building 3 important projects within our ETHGlobal ecosystem. So Bob itself is a multi-chain, multi-collateral stable token with optional privacy implemented via the ETHGlobal protocol, which is a DApp powered by ZK snarks, which allows this private micropayments between users. And one of the recent projects we also started working with is called Bob CDP, which is basically a protocol which will allow users to not only generate Bob by locking their stable collateral, but also use some of their volatile on-chain assets to mint this Bob using the CDP model. So just a few words about the Bob stablecoin. So the first typical question that is asked about the stablecoin, which you probably didn't heard about, is related to does the stablecoin preserve its price and keeps it back. So here we decided to follow the simplest possible approach, first of all, with just starting by backing each Bob with a similar amount of USDC. So for now, Bob, each freely available and circulating Bob is backed 1-to-1 with USDC, and all circulating supply is 100% backed with on-chain stablecoins. Yeah, and to further harden the peg, we're also using this concept of very tight concentrated ranges of liquidity on Uniswap v3 and similar liquidity protocols. Yeah, for hardening the peg and keeping this 1-to-1 ratio between other stablecoins, we also introduced this headless AMM called BobSwap, which is currently integrated to 1inch aggregator and Pathfinder. And we're also looking into integrating it into other AMM aggregator frameworks in the nearest future. And basically, BobSwap allows you to swap between other whitelisted stablecoins into Bob and from Bob with fixed rate, which is in zero slippage and almost zero fees. And one of the also other cool features it supports is called idle asset compounding. So whenever somebody logs some USDC or USDT in the BobSwap contract, this can be automatically auto-compounded to some of the blue chips lending markets like Compound or Aave to earn some additional and notable yield for the protocol revenue, so which is also a cool feature to have. And just to conclude about the Bob part, just to throw some numbers. So the current market cap of Bob is about 50 million USD, with achieving about 8 to 10 million dollars of trading volume daily. We have more than 4,600 active holders of Bob token, and the overall collateralized circulating supply available freely on the market is around 7 million. And the Bob itself is deployed on multiple chains. We are looking forward to deployment on other chains as well, but right now we are present on Polygon, Optimism, and Arbitrum rollups, Ethereum mainnet, and BNB chain. So yes, as I said before, we also started working recently on this module for collateralized debt positions, which is soon going to be available on one of the Bob present networks. And this way, users will be able to generate new Bob on the market using their Uniswap v3 or QuickSwap v3 LP positions with Bob or other token pairs as collateral. And this way, it's going to increase the capital efficiency and allow for more collaborations for us in the future. So now jumping into the coolest part, the ZK Bob. So the ZK Bob is a optional privacy layer for Bob token. The way it works is by using the zero-knowledge proofs. People using ZK Bob are able to confirm the particular validity of the particular operation and transaction without actually revealing the concrete details, sensitive details of their deposit, private transfer, or withdrawal, such as the amount of their operation, the destination addresses. And so they confirm this validity of this operation by using and calculating the zero-knowledge proof, snark proof, within their application UI. And this way, only the actual sender and the receiver of each particular operation has the ability to actually access and decrypt the operation metadata and to actually know what happens inside of this operation. Then, to limit further privacy leakages and to simplify the use case, the way how this protocol is used by the users, all transactions are sent through the elected relayer so that users don't actually need to pay for gas in gas tokens, and instead they can use the same token for payment of fees to the relayer as the sending, which is the Bob stablecoin. So here's a small snippet from the UI. So basically, as I said, the UI allows you to make a deposit inside your privacy application from your public wallet on Polygon or other available networks. Then you are able to perform transfers to other participants within the ZK Bob pool. And finally, once you, for example, receive the salary, you are able to withdraw them back to your public wallet to continue your DeFi journey. So right now, we are looking for collaboration in multiple major use cases. So the biggest one we are currently focusing on is related to everything somehow connected to payroll activities, invoicing, payments processing. So basically, a lot of organizations in crypto and beyond, a lot of DAOs are already paying their salaries in stablecoins, which is a convenient choice of currency for payment of salaries, and paying them and keeping them on chain is a very beneficial use case. But usually this all happens publicly on publicly available blockchains, which makes it very inconvenient for everyone involved. So for DAOs, it makes inconvenient to disclose everyone's salary to everyone. For people receiving this salary, they can be scary for receive salary on publicly available address so that everyone on the blockchain can see how much they receive, how much they spend, and how they spend it. So it makes a perfect fit for the privacy application connected to stablecoins to kind of try to integrate with all those who are paying salaries in stablecoins. Yeah, and we are also focusing on other use cases as well, which might include something related to vendor purchases, anonymous donation, fundraising, granting programs, and the connection to the TradFi world and its use cases like on and off boarding between stablecoins and traditional banking, processing of bank deposit, remittances, and so on. So, and as I said, with the example of salaries, for example, how it all works. So we have our employer, Carl, let's say, who wants to pay for his people and employee privately. So he has USDC, let's say. He's able to go to Uniswap or 1inch UI to swap his USDC to Bob at a nearly 1-to-1 rate, then deposit this whole amount to the ZK Bob application. And then when the day of the salary came, he's able to, within one transaction, to pay for all of his employees using their ZK addresses. And then once the employees receive their salary, they are able to freely withdraw their Bob back to the public wallet. And so nobody really knows how much each employee receives and what he does further with his money. So right now, the ZK Bob application is available only on Polygon and Optimism, but the Bob token is present on multiple chains as well, and as well as people are using other chains as well. So for further kind of simplify the UX for our users, we also made this cool integration with LeFi. So you have access to the widget of LeFi within our application, which actually allows you to perform quick, efficient, and fast swaps cross-chain between your available assets and Bob, so that you can use it for deposits, or when you have withdrawn Bob, you can swap it back to other assets on any other available chain quickly within our UI. So now a few words about compliance and our approach to this topic. So first of all, we believe that compliance topic is becoming more and more important every day for every crypto project, and especially it's true when we are talking about privacy-related applications. We have seen a lot of events in the past years which were related to the privacy solutions and the lack of sufficient compliance solutions. So we also believe that no actually single compliance solution exists that can fit and close all the use cases and eliminate all the questions from all of the regulators. So we believe that the best approach we can choose here is to combine multiple compliance approaches, which every on its own make life of malicious actors a bit harder, while still preserving the decent amount of simplicity and robustness of the user experience within our application. So what we are doing on the compliance side within our application, we are passively screening the deposit and withdrawal addresses so that no malicious actors related to known exploits, hacks, or other types of illicit on-chain activities are able to perform operations within our privacy protocol. We also will soon start to allow our users to generate a cryptographically verified statement of their account, which includes a history of their transactions for last 3 months or so that they're able to generate the report and to prove to the requesting party, which could be a centralized exchange, the banking institutions or government authorities, what they actually did in the pool, where did they receive their money from, and how they spent it. And so this way they're able to prove the source of funds, the way how they spend it, without disclosing it publicly to the whole blockchain, but instead to just disclose them to a particular requesting party. Yeah, we're also imposing different limits on the amount of activity certain actors can perform within the pool. So we have a strict limit on the amount of daily activities you can make on the deposit and withdrawal side. We have the limit on the total pool size. All of this makes life really harder for the hackers and exploiters who want to deposit and operate on large amount of money, but at the same time, it doesn't really make life harder for typical users of our application who just receives a salary or perform day-to-day transactions. We also did a cool integration with Binance and Know Your Cat KYC provider, which is basically allows you to mint to your address to pass the KYC on Binance, then to connect it to the KYC enabled soulbound NFT token, issue that on your wallet, and our application will check the existence of this soulbound NFT on your account, and if it's present, it will can lift or significantly increase the available usage limits for the application. Yeah. So, and one of the latest feature we have added to the ZK-Bob, and the one we are asking our hackers to use throughout this hackathon, is called direct deposits. So basically, it's a solution for simple and fast private payment integration within different partner products. So its main goal is to minimize the required effort and coding for when it comes to integrating privacy features to open source wallets, third-party decentralized application, different protocols, DeFi-based applications, and so on. And so the coolest part of that is that even though all of the previous ZK-Bob operations, such as deposits, transfers, and withdrawals, they require users to actively participate in the generation of the snark proof within their UI, which makes it nearly impossible to integrate such workflow within partner products. In case of direct deposits, no actually ZK snark proofs generation is required for the user, and instead, another third party is responsible for generation of those snark proofs. So the way it works is pretty simple. So we have this potential, just a few ideas who can integrate direct deposits. So it could be text protocols, donation fundraising platforms, different cross-chain bridges and protocols, maybe open source wallets who want to simplify the life of the users, maybe some tooling related to payroll and invoice processing, which is located on chain. And so all of these protocols implemented in some form of smart contracts can easily interact with the escrow smart contract for our direct deposit processing logic. basically by specifying the destination ZK address of the users they want to send their money to, specifying the desired amount. Then after some time, normally it takes 10 to 15 minutes, the relayer, which is relayer hosted by us, will be able to process those pre-submitted direct deposits in batches, generate the necessary snark proofs for them in a trustless manner so that no one is really able to manipulate the data in the direct deposits after it has been submitted. And once this transaction from the relayer is eventually submitted to the pool contract and confirmed users of the ZK-BOB are the receivers of those direct deposits are able to access the funds right away in the same way as they do by simple interaction within our ZK-BOB UI. So users can continue to transfer them inside the pool to other participants or withdraw them back to the public 0x address. So now a few words about our hackathon bounty. What we are asking you to do is to help us to bring the financial privacy and to find the important everyday use cases which lacks this financial privacy for stablecoin transfers, and to connect ZK-BOB with any existing on-chain activities where it might matter. And so we are asking you to do so by integrating the ZK-BOB direct deposit feature with any existing or your customly built protocol, project, or any other application of your choice. So just again, a few ideas where can we start? We can build an integration with open source wallet for making deposits into privacy pool easier and more available for public usage. You can integrate it as a endpoint and at the different protocols related to bridges, swaps, and the aggregators. You can do something with the processing of fundraising and donation from multiple users, or you can build something around the payroll tooling. And of course, this list is not limited by only our ideas. You can suggest and discuss any idea you have in mind right now or later at our booth as well. So we have a total bounty of 10,000 BOB for this hackathon, for the 5K for the first place, 2K for the second prize, and the remaining 3K will be evenly distributed among all successful notable submissions. So basically all projects which successfully will be able to integrate ZK-BOB direct deposits in their projects will qualify and receive guaranteed bounty within this from this prize pool of 3,000. Yeah, and during the judging process, we'll definitely take a look about creativity, novelty, and the implementation quality of your solution, how the ZK-BOB integration is actually crucial and integral to the overall application, and how your solution aligns with the BOB and ZK-BOB ecosystem values of on-chain compliant privacy. Yeah, and I think we have a few minutes for a short live demonstration of how direct deposit works. So I'm going to log into the ZK-BOB UI right now. So I have created previously, a couple of days ago, a test ZK account. So we're going to wait until everything is loaded. So what we see here is that I have a ZK account. I have connected a public MetaMask address to it, on which I have right now 5.9 BOB tokens. I have a ZK account with a total balance of 14 BOB. If I go to the history, yeah, I will see that this balance of 14 is obtained usually. So a couple of days ago, I made a deposit of 8 BOB. Then someone transferred 2 more BOB to my receiving address, to my receiving ZK address. And finally, I made a direct deposit to this address, to this account as well. So in order to just do one more direct deposit to our account, we're going to need to send 2 transactions. So just for the purpose of this demo, the simplest way we're going to do it is through Polygon Scan UI. So this concrete deployment is on Polygon. So the first transaction is we need to actually approve the tokens, the BOB tokens for usage into the direct deposit contract. So that's a quite a typical flow for any Web3 application. So we're going to send an approval transaction. Yeah, so it's good. And then in order to send the direct deposit from the Polygon Scan UI without generating any snark proof, we're going to create a new receiving ZK address in our account tab. We're going to go to the second direct deposit smart contract. And here we're going to find the direct deposit function for making such deposit. So we're going to pass an address we want to make our deposit into. Then we're going to choose the amount. Let's say we want to deposit 3 Bob tokens. So the Bob has 18 decimals. So we're going to also type 18 zeros. And the fee for depositing is 0.1 Bob. So we're going to add that here as well so that the receiver will actually receive 3 Bob. And then we also have a third parameter of fallback user, which is basically alternative receiver for this particular deposit in case it cannot be made through due to some compliance issue with the sender or similar problems. So since we are sending the deposit to ourselves, we're going to just copy the same address we use in our MetaMask here. I'm going to send this transaction. So we're going to see that from our account, 3.1 Bob will be eventually deducted during this transaction. So yeah, and once the transaction, let's wait till it's displayed. So yeah, we have successfully submitted a direct deposit from our address to the ZK direct deposit smart contract. So now we're going to have to wait for 10 to 15 minutes for Relayer to pick up this transaction, to put that in a batch, generate the necessary snark proof, and submit it to the main ZK pool. And after that, we're going to see the one more incoming transfer of 3 Bob with this direct deposit label on our account, and the total balance of our account would be increased to 17 Bob. So yeah, that's pretty much how it works. Yeah, so feel free to subscribe to our Twitter, read the docs about ZK on our website. We have a cool page specifically for this hackathon regarding direct deposits. Come to our booth for any questions, for any other collaborations, for grabbing our cool swag. Yeah, ask questions in the sponsor ZK hackathon Discord channel at the ETHGlobal. And yeah, thank you very much for your attention. I think we have 5 minutes for questions here, if you have any.
So if you have any questions, so please raise your hand. So I'm going to bring the mic.
Yeah, so how volume dependent is the privacy protection? So like, if there's not that many people doing deposits and withdrawals, is it easy to track, like linked together the transactions?
Yeah, so of course there is a well-known concept of anonymity pool. So it works differently in different protocols, since in our protocols there are not only deposits and withdrawals on some fixed amounts, but you can also after you make the deposit, split it in multiple withdrawals, so make transfers within the pool. So actually the funds become really dispersed over time pretty fast. And so if you, even within like hundreds of users, it really becomes nearly impossible to tell what really happens and how are they connected. So yeah, basically I think even existing anonymity set for the ZK is already quite enough for the majority of people. So if you're gonna go into the contract, open the token transfers, yeah, we'll see that a lot of stuff going on here, and there is actually no any way to tell how these depositors and withdrawals are connected with each other, how they exchange the money within the pool. So it becomes quite untrivial to reverse engineer.
What is the best way to so is there a way to withdraw fund on chain?
Yeah. So basically, once you have this balance within the ZK account and you want to withdraw to your public address, you're gonna just select the withdraw tab.
I mean, without the UI, is there a way to call that on Solidity or?
Yeah, so it's not possible to call it directly on Solidity, since in order to withdraw, the user must generate the snark proof. So the Solidity on its own cannot kind of generate the snark proof. So right now, the only option is to use the UI for generating these proofs. So we have like a more low level for like this WASM library, which is responsible for all this proof generation necessary SDK. So maybe we're going to build some widgets which are going to help to integrate this into some other external UIs in some time in the future. But yeah, anyway, so there is this low-level library which is responsible for proof generation, and this probably going to be the only way the person is able to initiate and submit their withdrawal.
One thing quickly. Is the Bob swap deployed on any testnet now? Any testnet like Goerli or Seporia?
I think no, unfortunately, but yeah, probably we can deploy it, so no problem. So yeah, it's deployed on Polygon, Optimism, and all other networks. Yeah, integrated with 1inch, but yeah, if you want it to happen on Goerli or Sepolia, yeah, we can definitely do that, no problem. Not right now, but yeah, maybe within this hackathon, yeah, I'll try my best, yeah.
How strict is the deposit screening? Like, would a wallet freshly funded from Tornado be sanctioned?
Well, I think you can try. I'm not sure it will be immediately flagged, but so we are using the TRM for now as our screening provider. So we kind of do not screen ourselves. So we don't. I'm not 100% sure what are the policies within TRM, how this score factoring depends on the different sources, on the amounts, on how you like on the different timings. But I think it obviously marks very obvious use cases when someone launders hundreds of millions of dollars. Yeah, definitely gonna mark those. Definitely not gonna mark, casual wallets of simple users who are like transferring, value of below 1,000. But what happens in the middle, it's really hard to tell usually. And so, yeah, it all depends on how this TRM provider behaves, and they do not actively disclose what are their politics and how they calculate these score factors.
What was the name of the people in charge of the sanctioning again?
TRM Labs.
TRM?
TRM.
Oh, okay.
Yeah. Thanks for stopping by. Thanks a lot.
Yo, I'm York. Welcome to Permissionless Interoperability and Warp Routes. I'm from a project called Hyperlane. We're a interoperability protocol focused on modular security and bringing interoperability to all chains. So we're very chain agnostic. We're hoping to kind of support whatever chain you guys want to be working on in this hackathon. You can stack some bounties. This is my colleague Nam. We're going to hopefully do a live demo for you guys at the end here. Fingers crossed. But yeah, first let's hop into what is permissionless interoperability and what are warp routes, and why should you care? So just as a definition to start with, interoperability in our eyes is composability amongst dApps that are on different infrastructure. So whether that's like a dApp that's on an L2 composing with a dApp that's on an L1, or Cosmos app chain with a dApp on Ethereum, or something more exotic. That's what we define as interoperability. And if you look at the dApp ecosystem in the past couple of years, what you'll find is that the infrastructure that dApps are choosing to deploy on is kind of increasingly divergent. As people start to realize the benefits of different trade-offs throughout the kind of layers of the blockchain stack, they're choosing like more and more diverse trade-offs. So, we have kind of the hot stuff right now is like data availability layers, like having this infrastructure layer that's optimized for this specific task. There's also a lot of people thinking about app chains and kind of the different economics that you can capture as a dApp developer by kind of controlling the entire blockchain stack. So these are just a few examples, but it should be abundantly clear by now that like this is only going to become increasingly diverse. So the Ethereum ecosystem's focused mostly on kind of the roll-up side of things. They've kind of committed the past couple of years to that scaling strategy, but it's by no means kind of like, I think, a final destination. They still want to work on these other things, plasma, sharding, et cetera. And we're seeing dApps adopt these new roll-up architectures in the Ethereum ecosystem. So Arbitrum Optimism, kind of the two canonical examples of like big roll-up ecosystems. There's a bunch of DeFi happening on both chains. And the challenge for dApp developers is the developer interfaces for interoperability between like all these different layers is super fragmented. So each one of these rollups, like let's say Arbitrum and Optimism, they all have a custom like bridge implementation. And so if you want your dApp to be interoperable between like Arbitrum, Optimism, and Ethereum, you got to implement like 3 different interfaces. Depending on what you're trying to do, the action, like you have to use a different pathway. So like deposits and withdrawals are one pathway. And then there's like separate pathways for bridging wrapped assets, or doing like arbitrary message passing or arbitrary contract calls on these other chains. Like all these generally, you have to like use some different pathway. Maybe like the canonical bridge doesn't provide this, or it doesn't provide it at a latency that you're happy with. And so, yeah, this is like super hard as a dApp developer to actually like take advantage of all these new things. So typically what we're seeing is people are just choosing a roll-up. They're like, oh, I think Arbitrum's winning, so like I'm just going to be an Arbitrum dApp. But there's no reason that they should have to take on that risk of making that choice so early on in their product development. These are just a couple examples of like things that get unlocked once we start getting like real interoperability between heterogeneous blockchain architectures that at the infrastructure layer provide different capabilities or features. So I'm going to move quickly through this. yeah, I'm going to also just move quickly through his. But okay, so Hyperlane's kind of one of Hyperlane's core ideas or insights is that in order to provide this like modular interoperability layer that developers can use across all these different infrastructure layers, we need to separate the transport layer and the application layer. And so at the application layer, we can have a consistent interface that developers can use across all of these different infrastructure layers. And depending on the kind of pair that developers are having communication move between, the transport layer might look slightly different. But all of that is going to be kind of abstracted away from the application interface that like dApp developers need to understand. And this allows dApp developers to basically no longer have to think about like maintaining multiple implementations of their protocol for different chains, for different rollups. And furthermore, like dApp developers should be able to express their preferences for security and kind of the trade-offs that they want to make in their application. So if you look at kind of like the canonical rollup bridges, like we just talked about Arbitrum, Optimism, you know, we have a very specific fraud-proof mechanism that implies some, you know, security constraints, some latency, but it's this like omnibus model that all applications on that rollup need to opt into. And that might not make sense for your application, or it might only make sense for like one type of action that happens in your application, but otherwise, you know, you maybe don't need all that security, or you'd prefer the lower latency, like faster finality settlement pathway. So we want to allow dApp developers somehow to express their preference for these trade-offs in the interface. And as stronger verification mechanisms become available from kind of the R&D side of the ecosystem, like a bunch of people are working on, you know, ZK Lake clients, all this like signature aggregation stuff. As those become available, the dApp developer can just change a very simple configuration without changing any of their implementation to say, hey, I'm going to now apply this new security module to these set of actions that are happening between these set of chains. And that's just like a configuration layer in their smart contract instead of like a whole new implementation that they need to do to now like go and verify some new security models like messaging format. Yeah, and the final kind of like core idea that we're excited about at Hyperlane is extending this capability and this developer interface and like modular security paradigm to any chain that you guys want to be on. So we have a feature that we've been like working super hard on recently that we call like permissionless deployment, and it's this idea that someone who's like maybe spinning up their own rollup, let's say they're using like the OP stack or something, they should be able to just bring Hyperlane there independently from our organization. And so like we've basically built out the tooling for developers to deploy our protocol to their chains. And this is just way more scalable than what we've seen with like the existing bridging and messaging providers, where you have to kind of go and like lobby them, and like they have to take on some amount of risk to operate on your chain, and maybe there's like not enough economic incentive for them to do that. Yeah, so this is hopefully what we're going to live demo today in a moment. Already went through that. Cool. So switching gears a little bit, the application that we're going to try and deploy today across a few different chains is called a warp route. A warp route is basically like this collection of contracts that allows you to route tokens between chains. There's a few different flavors of our warp route implementations. We have like the native flavor, which allows you to wrap native assets, like let's say ETH, and in like a single transaction, route them to some other chain. The collateral flavors for like existing tokens. And then synthetic is for how to represent those collateral tokens on chains where they're being warped to. So a warp route is like some collection of these set of primitives. And I'm not going to go super in depth here, but you should definitely check out our docs. I think the basic premise is like I don't even really want to get into the kind of how Hyperlane protocol works in this workshop because I think it's like less interesting for the hackathon context. But there's a bunch of stuff going on here. You can imagine Bob being like a recipient application. And the idea is Bob can specify his security preferences for like what types of warped assets he wants to accept into his application. So whereas today we have like, let's say wormhole USDC that's like bridged everywhere that has some kind of like global security model that everyone is basically opting into if they're like using wormhole. You can actually like have different, I guess like you can almost look at them as like tranches of a warped asset that is like using some specific risk tolerance or security model to verify that like those assets have indeed been kind of locked up and collateralized on some other chain if that's the instantiation. Cool. So yeah, we've basically like built a bunch of off-the-shelf tools for you guys to play with this like warp route primitive. So the idea is like you don't even have to necessarily write your own contracts. You can deploy one of these warp routes between any chain that you want to deploy Hyperlane to. And that'll allow you to just like import liquidity. It's like a big use case that a lot of new chains are really struggling with right now because in order to like launch a new chain, you need to establish some reason for people to like come to your chain. And that usually implies like having some economic activity. And so you need to bootstrap that somehow. And an easy way to do that is just like importing liquidity from some existing chain. You kind of like can leverage existing network effects. But if there's no token bridge operating to your new chain, you can't do that. So the combination of like being able to deploy Hyperlane to your chain and like having this nice warp route primitive allows you to like spin up a chain which can like solve this kind of cold start bootstrapping problem. Cool. So yeah, we have a bunch of different tools here for what I just described. I think Nam is gonna try and demonstrate us deploying Hyperlane to a testnet and then deploy a warp route between that testnet and maybe some public testnet.
Let's get this up. Cool. All right. So, like York said, we'll be doing a live demo of what it's like to deploy Hyperlane to your own chain. So let's set the context here. Let's say, right, like you create your own rollup and you're just like, oh, this is all great. But like, obviously now you have to convince, right, like developers and users to come your own rollup. And right, like traditional world, like you maybe have to convince, I don't know, like Coinbase or Binance to ultimately list your token for people to actually be able to like move economic value to your rollup, right? Oh, like to your own chain. What, like I'm just using rollup as a specific instance of that. And so now with Hyperlane, you can basically deploy interoperability to your chain and connect it to any other chain that is connected to Hyperlane. And so that's what we're going to be doing. So, right, so on our docs here in our guide, we have this kind of like 5-step process of deploying Hyperlane. So the first step is just generating keys. So I guess that doesn't even count as a step. The second point is to basically deploy contracts. And so we have a Hyperlane deploy repo, which I've kind of cloned here already. And basically all you have to do is you have to add your chain, right? So basically in chains.json, oops, actually this is the wrong one here. Basically in chains, you just kind of add your like chains information. All of this really like the name, the chain ID, and then an RPC URL. So in this case, we're going to be deploying to Coinbase's new chain called Base, right? And obviously if you're Coinbase, you know, I guess you have your own exchange, but again, if you have, right, like deploy your own rollup here today, it's going to be very hard to convince anybody to deploy anything on your chain. So here's going to do it ourselves. So all you have to do is basically add your chain here. Like York said, we have modular security. And so like in this case, what we'll be doing is we'll just deploy like a 1 out of 1 kind of like multi-sig ISM, as we call it, to basically validate messages going from your chain to all the other chains. But actually, you get to reuse the security that we already have existing like kind of default chains, as we call them. So for us, we should just be deploying between, let's say, Base and Sepolia. And so then all you have to do is, I guess I could just copy and paste that here. So basically, you add your chain, you kind of configure the security, the default security from your chain, and all you have to do is like run the script. Right, and I'm not going to like deploy this because it's like a bunch of transactions going to take a little bit too long. But at the end of this deployment, you basically get kind of these addresses. So in here, you get basically all the artifacts of the addresses that got deployed on both Base and Sepolia. And so that's kind of just the contracts. And then the 2 remaining steps are basically to run the validator, which basically validates state from your chain, in this case Base, to all the other chains, right? So that's the first step. So all you have to basically do is kind of run. We have Docker images, or you can just build it from source, as we did here. And you basically say like, hey, like what's the origin chain name that I want to validate on? Where do I want to write my signatures to? So in this case, I'm just writing it to a local folder. And then basically the config file that you got from the contract deploy. And so basically once you run that validator will now observe the contract on your own chain. And basically anytime there's a new message, it will kind of like attest to that new message. The next step then is, after running a validator, is to run a relayer. And so basically a relayer is a permissionless role that basically uses the signatures from the validator to ultimately pass them on to the destination chain mailbox contract. Right? And that mailbox contract basically then uses the security module that is specified to validate, hey, did this actually happen on the origin chain, and then process the message. And so basically we have relayers that run basically from like one chain to another. So in this case, you can see here, I think this is from Base to Sepolia. So we'll just run that right here. And then equivalently, we have another relayer that runs from Sepolia to Base. And so that's basically all the kind of like off-chain infrastructure that you would have to run. And now we're connected. We can kind of like easily, there's a test script that can run right now that basically just sends 2 messages, one from Base to Sepolia and one from Sepolia to Base. And then we should see those being delivered in 1 second. If all goes well.
Yeah, I realized I didn't like go into a lot of depth on like what's happening at the smart contract layer, but just to provide some color there, like when your contract wants to interact with the contract of another chain, it needs to send a message kind of describing that interaction, and that message needs to be authenticated such that someone can actually know that it was your contract that dispatched this action rather than some malicious attacker. And so we have a few different security models that you can select off the shelf to like perform that authentication. One is this like multi-sig validator setup, where basically there's validators on the source chain that are signing commitments to the messages that have been dispatched from that chain, such that those signatures can be used on the destination chain as an attestation that, hey, this message was dispatched on this source chain. Eventually, the idea is to have kind of like permissionless economic security model where anyone can be a validator if they're putting up enough stake and provide security to this type of authentication system. But yeah, what's happening here is the message is being committed to on, let's say, Sepolia, and then the validator that Nam's running on his machine is signing commitment. And then the relayer that he's running on his machine is taking that signature and passing it to the destination chain contracts, which is like one of these warp route contracts that's basically verifying, like we saw in the multisig ISM config that he had up earlier. It's verifying that we've reached a threshold of the specified validators that have like attested to the fact that this message was like committed to on the source chain. But yeah, definitely for more details, check out our docs on kind of all the different types of security configurations.
Cool. So basically now that we've kind of verified that we can send messages back and forth, right? Like we've kind of connected this new chain that didn't have Hyperlane before to all the other chains that have Hyperlane. And so now that you have kind of this base messaging layer on kind of set up, you can build applications on top of that, right? And like York said, I think a very common application is effectively a token bridge, right? So let's say, again, if you're a new chain, like one of the first things you probably want is like you want a stable coin, right? And so why don't we just kind of like create a warp route of, let's say, like something like USDC that exists on Sepolia to like your new chain, which in this case is Base. And so we once again have a guide for that, right? So under warp routes, here you, again, just go off Hyperlane deploy and you just run a different script. The script basically is configured with this warp route config. So let's say in this case, warp route, where is it? I guess we call it warp tokens now, right? So that's basically we say like on the base chain, which I guess is like the collateral chain, we basically say like, hey, we want to collateralize this token, which in this case I think is just a link token because there's a good faucet on it on Sepolia. And basically we want to say like, hey, we want to create synthetic versions of that token on, let's say, another chain, in this case, our base token. I see how that naming can be a little confusing in this particular instance, right? But basically we allow now to create a warp route between Sepolia and base. And so then all we have to do is, what's it called? Deploy warp routes, right? With basically our private key to kind of deploy the contracts. And I think that's what happened above here. So again, I'm not going to run through it because the transactions take, I think, a couple of minutes. And the cool thing is that like once you've kind of deployed this warp route, right, which is basically just a set of smart contracts on both chains, we actually have a like out-of-the-box UI that you can use to kind of let your users now leverage this warp route to kind of have these like synthetic tokens. And so all you have to do is basically take the output of your warp route deployment and basically add that to this like template repo that we have that you can clone. Again, all you have to do is add your chain information in here, and you add the token information from the warp route deployment. And I can do like, in this case, I can just like kind of run it locally right here, but it also like super easily deploys to Vercel or any other like Next.js hoster. And so basically then here on localhost, let's see, it will basically fetch kind of the warp route information, and then after a little bit, we'll show you, right, like the kind of the chain options for your warp route. You can see the token that you can kind of warp. You can say, hey, I want to send this much. The recipient, you can just say it to yourself, and then basically send it to base. And again, this is all out of the box, right? I didn't have to change any code. It will prompt me to approve my link token to the warp route contract on Sepolia. And once the approval happens, and if the Wi-Fi is good enough, ultimately it will.
If you guys saw the Layer Zero, like Gorley ETH market drama a couple of weeks ago, this is like a tool where you can create those type of markets between any chain's assets super easily. So if you guys want to, like in this hackathon, go mess with someone else's testnet, you could maybe do that.
Cool. All right. Then we saw basically the second transaction, right, is to actually ultimately send the tokens over to Base. And so that, I guess, just confirmed on Sepolia. So like York said previously, again, like validators will basically attest to that transfer on Sepolia, create signatures, and then the relayer that I'm running right here will basically observe that message and will ultimately process it on Base. And so I think what we can do actually is just to take the yes, so we can basically take this is the token address on Base, right? So we can just go to Base, I think, what is it, Base Etherscan? I forget what it is. What was it? I just had it. I think they call it Base Scan. All right. And then you can kind of put in the token address, right? So that's basically like, you can already see here, it's like shows up as Chainlink, even though I'm pretty sure Chainlink doesn't have it deployed the token on Base. And then under, I think that tokens transfers, you can see here, like 25 seconds ago, we just minted ourselves 0.001 Chainlink token on Base. And then I think in the UI, like you can kind of see the same thing. And then like if we wanted to, right, like we can send it back from Base back to Sepolia again. And you can imagine what the kind of outcome of that is. I'm told we're out of time, so if you have any more questions, feel free to jump by our booth today. We have 3 bounties. One is for the best use of permissionless interoperability. So basically, right, like you can deploy to many of the networks that are represented here today as well. And kind of like, would love to see kind of some cool use cases between, let's say, like, a new chain and like an existing chain. The second bounty is for best use of the warp routes, right? So like bring your token to some new chain and kind of do something useful for that. And the third is, like we said, we have this kind of modular security approach where developers can choose different trade-offs. And we would love for developers to kind of build some kind of like alternative models, like an optimistic one, or like maybe one based on succinct, like kind of like ZK light clients. But like, because we believe that the story hasn't been kind of finished telling yet about what security models they're out there for cross-chain interoperability, we would love for hackers to kind of like play around with that. I think that's it. Thank you.
Maybe we want to let people for a second.
Hello. Hello, everyone. Huge audience today. It's really great. Really appreciate it. Hello, everybody on the live stream and that's tuning in later on. My name is Jeff Wentworth. I'm co-founder of a company called CurveGrid, and this is a 30-minute DApp. So what we're going to do for the next 30 minutes is basically walk through building a sample DApp, and we're going to show you how it's possible to do that faster and easier than it might be if you build everything from scratch. So basically what we're going to do today is not only talk about building a DApp, but also some of the challenges that you encounter building a DApp, and then talk about some, let's say, bonuses that you know, might help you more broadly in your DApp building experience. So first of all, as I mentioned, my name is Jeff, co-founder of CurveGrid. We're actually based here in Tokyo, Japan. We have been in business since 2017 for 6 years, and mostly we tend to be in the background a little bit. So our customers tend to be blockchain companies or developers that are building different kind of dApps on EVM blockchains. And really, for the first time at this ETHGlobal hackathon, we're looking to connect with more individual developers in a much broader audience. So you can see us here in the red coveralls. We're here to help. We have 10 people at ETHGlobal Tokyo, and you know, if you have any questions about building a DApp in general, not just our product, but anything technical related, design related, or just about Tokyo and Japan, we're here to help. So creating a DApp, and in fact, whether this is some sort of production DApp or a hackathon like this weekend, there's a whole series of steps that you have to go through, including planning, the back end, the front end, the smart contract. We're going to talk about all of that, and then we're going to talk about some of the other ways that we're here to help you. So first I want to talk a little bit about multi-BAS. Multi-BAS is multi-blockchain as a service. So our whole theory is that this is and will be a multi-chain world. But blockchain is difficult to build on. And so what we're really all about is helping you get to market faster, more easily, and ultimately doing it with fewer developer resources. I talked a little bit about CurveGrid, the fact that we're based here in Tokyo, Japan. We have a number of different solutions as well that can help you. So in addition to multi-core multi-BAS, we also have a multi-BAS proof, bridge, and spreadsheet. The latter two are actually former ETHGlobal hackathon projects that we turned into products. And we also have NFTbot, which is a Shopify minting app for minting NFTs on Shopify. So what is a DApp? We're going to go back to first principles or basics. And again, whether you're building the next you know, DEX or NFT marketplace, or you're just hacking on something for the weekend, this is what a typical DApp looks like, right? Front end, back end, connecting to a node provider, smart contract on the blockchain. In the mix there as well, you have a wallet, whether that's a non-custodial or custodial wallet. You've got a database. Where multi-BAS sits in this stack and makes things easier is typically between your DApp front end and back end and your smart contracts. And the idea is that you're actually having to build less on the front end or back end, and less of kind of the core infrastructure. We take care of a lot of that for you. And so that's what multi-BAS provides. So we put together a sample DApp that you can use as a base for your work this weekend, or you know, even going forward. And our DApp is a NFT sprite maker. You're going to see it in a moment. You know, again, if you're thinking about putting together an application, the first thing you want to do, of course, is ideate, get your team together, and then plan, build, and submit. So throughout the next several pages, we have a QR code at the top, and you can find this sample DApp repo there. We also on our website, curvegrid.com, have a blog post that we've put up with a complete walkthrough of this tutorial, as well as other resources to help you get started in building a DApp. So the planning phase is typically user stories, design, user flow. You decide on your stack, front end and back end, and smart contract.
and then for the NFT sprite maker, this is all about, one of the key things that we want to do here was allow people to free mint. And you'll see what I mean with that in a moment. On the front end, this could either be used by end users or admins. We can talk about that a little bit more. And for the smart contract, we started with the Open Zeppelin Wizard NFT smart contract and built out from there. So here's our sample dApp. I'm actually going to go switch to it here. You can see it's just running on localhost. So it's called SpriteWrite. And basically what it allows you to do is draw some sort of fun picture here and then connect your wallet. We're going to do connect wallet. Come on, internet. There we go. Enter my password. There we go. Connect my wallet. Okay, I pulled up the wallet address. And what we've done here is we're actually allowing, we're actually with a custodial wallet paying the gas fees for the user to mint. So when I click mint here, it's going to send the transaction to the blockchain, and it'll show up a minute later once it's mined, and there we can go. We can see the sprite and the token ID and the owner and the time that it was last transferred at. We can see some of our past sprites. If you want to try this out, you can click on any of the past sprites to load it back into the canvas and then, continue drawing. So this is SpriteWrite, our sample dApp for basically writing sprites that we're going to be, demonstrating a few different things here. So what are some of the challenges you have when building a dApp? Well, the first is interacting with the smart contract, right? How do you interact with the smart contract? The second is around, in this example, is minting the NFTs. And again, the whole point of the sample dApp is we want to mint the NFTs for free for the user, right? So that they don't have to spend gas to do it. And then the third challenge is listing the minted NFTs. And the fourth one is managing the smart contract. So here's the structure of our sample dApp. And I want to, point out that on the left, you can see we have our, a screenshot of the dApp. As I had shown in the kind of typical dApp structure before, we have a front end and a back end. The front end's written in HTML, CSS, and TypeScript. The back end's written in Go. The front end is actually using two different techniques to get data from the blockchain. So first of all, the color palette is actually being pulled from the smart contract itself. The second is that we're using something called an event query to actually pull the table here, the list of sprites, of past sprites. And those are all going through Multibass to the blockchain. And then on the back end, the front end is also, of course, talking to the back end. We have our Multibass Go SDK that's talking to our HSM Transaction Manager, or TXM, to actually mint for free the sprites. So, what does Multibass do for you, basically? How would you set it up in a typical environment? Well, you would typically have both a development and a production environment. And the key differentiators here, the key differences here are, in your development environment, you would have developers with administrative rights, maybe your whole team of, say, 50 or 60 people, that might be making frequent updates to the environment. And then in your production environment, you're going to have your operations team with very limited access and updates, for example, controlled via CI/CD. So keep this in mind as we continue to go through. So how do you get set up on this sample dApp? First, again, you clone the repo, you sign up for Multibass, you set up your project, and then you understand Multibass middleware. So signing up for Multibass is super easy. What you do is you go to our website and you click on Get Started, and that will take you through a sign-up process. There's no credit card or anything needed, just your email address and name, and you're away. And as I mentioned, we have a whole blog post, an ETHGlobal Tokyo developer package, if you go to resources and blog, that basically walks you through all of the steps that you need to get started. In addition for that, we have extensive documentation, including articles and an interactive REST API reference as well. So you'll be well supported. Okay, so I've got my smart contract written. I've got this cool like Sprite smart contract written, and now I want to interact with it. How do I do that? Well, there's different tools that one can use, but in Multibass we've basically built that all into one package. So what I'm going to do here is I'm going to show you the Multibass web UI, and this would typically be used by developers during the development stage, and then the operations team during the ongoing production stage to essentially manage and interact with Multibass itself. So when you log in, you're going to come to the core contracts page. What you can see here is an interactive web UI that allows you to do a few different things. First of all, you get all of the static state variables at the top. You can see the output here. Here's the color codes that I mentioned before that are coming from the smart contract. We have the total supply. We have the symbol and the name. Then we have all of our events from the smart contract. And then we have all of our methods or smart contract functions. Basically, what we can do here is use this in a way to interact with the smart contract. So, for example, in this function here, get sprite image URI, if I come in here and I type in 0, get method, I'm actually going to get the data back from the smart contract. One of the nifty things we've done here is we've embedded all of the image data directly into the smart contract itself. So the smart contract is actually rendering the SVG file directly. So if I paste this data URI in here, I get my beautiful green field with the sun shining. But you could see, I think, how sort of easy it is to really interact with your smart contract this way, using the Multibass UI. The second way is via the REST API. And again, in addition to our documentation, we also have integrated REST API functionality built right into the Multibass UI here. So you can see how easy it is to really interact with the smart contract this way. In addition, we've got multiple SDKs right now in beta for Go and for TypeScript. And again, those are linked from the tutorial page. So you don't need to build, you don't need to build everything from custom with the REST API. The other thing, the final feature that I want to point out is that when you are interacting via the REST API, we have full role-based access control with both users, permissions, CORS domains, and a full audit log. And that allows you to build either a front end or a back end directly on top of Multibass. So, okay, great. I'm interacting with the smart contract via the web UI or via the SDK of the REST API. Now, I actually want to build a little bit more automation in there. And what I actually want to do, and what you saw earlier was we're actually paying the gas fees on behalf of the users that are minting the NFT. And we do this using something called HSM, which is basically a custodial wallet or quasi hardware security module that allows you to programmatically sign transactions and sign messages on the blockchain and submit them to the blockchain. At the moment, we primarily support Azure Key Vault. It's a cheap and cheerful, basically a third-party custodial service provided by Microsoft Azure wallet service. And in that tutorial, we have very easy steps to basically sign up for an Azure account, and then we have a PowerShell script that in one shot allows you to set up a key vault. You then load it into Multibass, fund the HSM, and you can interact with it via the REST API or even the web UI very easily. So I come back into Multibass here, I go to HSM and configuration. What I can see here is my HSM configuration, right? This would have been, this is coming from, again, or would have been loaded in from Azure Key Vault when I set that up. And then I also have my transaction manager. So I come into my HSM TXM, I can see all of my past transactions. This was the one that I most recently minted. And if I click into here, I can see all of the transaction details, including all of the decoded function parameters and event parameters that were emitted from here. So there's a very easy way that, either if you're working on something that is not publicly released yet, and so you don't want to confirm all of the data on Etherscan, or if you're iterating rapidly, you can very, very easily use the web UI again to manage this. So that's the HSM. Next, how do I list the minted NFTs? So there's a few different strategies for this in general. The first is you can iterate using smart contract functions through all of the all of the NFTs. One of the challenges there, especially if I'm using something like the ERC-721 enumerable smart contract, is it's very gas heavy. The second way is events, right? And really, this is the correct way, in general, to be interacting with smart contracts from a dApp off blockchain, off of the blockchain. The idea here is that essentially the smart contract is going to be emitting event logs, and you're reading those and then using that data to essentially drive your front end or your back end. The challenge with that, of course, is that the blockchain is eventually consistent, and it's very, very complicated to typically deal with this from scratch. So, often what you'd be using is a piece of technology called a chain indexer. We actually have a chain indexer built into Multibass. So if I come back to the Multibass UI here, I can go back to my contracts. I can take a look at Sprite right here, and I can see all of my events. And in fact, if I just copy and paste this, Sprite right, there we go. I can see, come on, there we go. I can basically get a really decoded JSON view of all of my event details, including, again, the transaction that initiated it, the parameters that were in the transaction, the decoded event parameters, time that it was triggered at. And this isn't coming from, it is coming from the blockchain, but it's via our intelligent cache, which handles things like chain reorgs, nodes restarting, everything like that. We have one additional feature built on top of that, which is called event queries. And essentially, this is a way to aggregate this time series data and report on it very, very easily. So again, even though the dApp itself, SpriteWrite, is being driven programmatically, this whole table is being driven by an event query. We can also go and take a look at that in the Multibass UI. If you come in here, you can see it's very, very easy to basically define your event queries, either through this interactive builder or just via JSON. That is events. Next, we have managing the smart contract. I'm not going to demonstrate this in real time, but essentially, we also have a built-in Gnosis multisig functionality that's built into Multibass. So what that allows you to do is essentially you can set up a multisig wallet, either link to an existing one, deploy it to the blockchain, and then if you set, for example, that multisig wallet to be the owner of your dApp, when you come into Multibass, either again programmatically or through our web UI, and you say do safe mint, if you select as your signer here that multisig wallet, Multibass will automatically wrap your transaction in a multisig transaction and either allow you to sign it via MetaMask or via your HSM and submit it to the blockchain. So we've basically taken all of the complexity out of away from dealing with multisig wallets and multisig transactions. Bonus time. This is the first bonus. So our spreadsheet plugin, as I mentioned, this was a Hack Money 2020 finalist project that we then over the subsequent months turned into a full-fledged solution. So what's the lowest common denominator for building any kind of application? I would argue that it's a spreadsheet. Like there's something like 9,000 smart contract developers in the world, something like 9 million developers in general, 25 million actually, sorry, 9,000 smart contract developers, 25 million developers, but there's 1 billion spreadsheet users. So what we actually have is we have a publicly available, it's available on the Google Docs or Google Workspace store. We have the Multibass for Google Sheets plugin, and this allows you to essentially, when you set your Multibass, when you install it and set your Multibass deployment ID and API key, you can come in here and in real time, you can actually query Multibass and essentially the blockchain in turn. So if I do sprites, query sprites, basically this is going to go out and call my event query and pull all of my blockchain data in real time into here. And you can say token ID 0 through 7. If I come back to SpriteWrite, and let's say I load in my my smiley face here and put a little pink hat on top, and then go mint. again, it's driving my HSM to mint that to the blockchain. I come back to here, and it's a spreadsheet, so I actually have to do something a little funky and delete this. There we go. Put it back in because it's Google Sheets. But what you should see in a second is I've got my token ID 8 that was just minted. So this is another option, and it's great for both debugging as well as, let's say, if you're a company, your finance team, or you want to do any kind of reporting, very quick reporting on your smart contracts. We can do things like we can call any arbitrary on-chain function, and of course you can use your aliases as well, which is another I think key thing that helps you go a lot faster with multibas. So we're going to do, let's say, balance of this address here, and it's a spreadsheet, so I can just use all of my standard spreadsheet semantics. And you can see that this owner, this address here has not a balance of 9 on my ERC 721 smart contract. That's bonus number 1. Bonus number 2 is NFT pot. So Multibas is our main product, but also last year we released a Shopify NFT minting app that allows you to easily create, mint, and sell NFTs on Shopify, either through lazy minting or also through importing existing NFTs. And it's super easy to integrate into your Shopify store. Shopify's logged me out, but so I'm not going to show that to you right now. But basically, just add this into your store, and you can immediately be building store that allows you to sell NFTs. So that's another option for this weekend. Actually, if you are less into code and more into e-commerce, we're happy to have you build on NFT Pod as well. Super bonuses. We've actually prepared a public GitHub repository. It's going to go live a little bit later tonight, but if you're interested in it, come talk to our team. With all of the, or no, I shouldn't say all, many of the other sponsor smart contracts preloaded with an easy script to essentially get you up and running in Multibas. Regardless, what you'll see in the sample tutorial repo is we've got we have a hard hat and truffle plugins for very easily loading your smart contracts into basically Multibas at the same time that you deploy them on the blockchain. So I'm actually going to show you that now in real time. So I have all of my minted sprites here, and I can see on Multibas, I also have, for example, a total supply of 9, and here's all the sprites that I minted. I'm going to flip over to my terminal, and I'm going to go yarn, yarn deploy sprite write testing. So standard, yarn or npm script with hard hat. And with the Multibas plugin, it's basically going to go and redeploy the smart contract and relink it to Multibas. And when I come back in here, you see that all of my old sprites are gone because it's a new contract version, and I'm just left with my what I had preset up. Okay, great. So in closing, we would love for you to use Multibas. We'd love for you to try it out this weekend. We've been working with different companies for many years, helping them get their dApps to market much, much faster. But even if you don't use Multibas, we're based here in Tokyo. We've got a big team. We're a little bit visible with our red coveralls on, so it should be pretty easy to find us. We're happy to chat about Multibas. We're happy to chat about dApp development in general. We've got engineers, designers, marketing and business folks as well. So we're happy to help with any technical questions or any questions about Japan and Tokyo. And I should mention our prizes. So our total prizes are $2,000. We have $1,000 for first place. Second place is $700, and third place is $300. And for anyone that just that incorporates Multibas in some way into your project this weekend, we're going to issue an NFT that may be redeemed for physical merch later on, again through Shopify. So we'd love for you to participate and join us. So again, QR code for the repo is there. Our blog post has more details on the tutorial, and thank you.
Yeah. So as we're using the API, do we actually have to like necessarily plug the wallet to some Azure Key Vault and then like have that specific plugin, or can we just like fund any normal wallet and then hey, at our risk and perils though?
You can fund any normal wallet. You absolutely don't have to use. Azure Key Vault. That's only if you want to use the HSM functionality. So it works really well with MetaMask or any other Web3 wallet as well. So for example, if I come over here and I go to the multi-token smart contract and I click deploy, and let's say I just plug some values in here, and I hit deploy. I'll get a MetaMask pop-up asking me to deploy the smart contract, and I'll confirm that, and there we go, smart contract's deployed. And I can see the deployment transaction here, and I can start interacting with it right away. So yeah, absolutely not a requirement to use that.
Thank you so much. All right.
Any other questions? I think we do have a couple minutes left, actually. So yes, please.
So do you have event webhook?
Webhooks are coming. Webhooks are absolutely coming. Something that might help you out there in the SDK is it allows you to basically do polling for now. And again, with our event queries, where you're not waiting on the blockchain node, you're not spending any let's say credits with blockchain node providers. Yeah, it's super easy. Often requested feature. It's coming soon. Any other questions? Okay. Well, thank you very much. Happy hacking.
I just want to check if the internet is working. First, let's go. Yeah, hopefully it is. Okay. Should I start? Yeah. Hello everybody. So, am I audible? Audible? All right. So, we're going to talk the least and do the most number of code developments we can. So if you have a laptop, just open it because it's going to be a lot of fun. Hopefully by the end of this particular workshop, you should be able to deploy a subgraph and understand what the graph does, which is basically indexing blockchain data. So what is basically indexing? Indexing means getting information which is already existing in the in the database in a more skewed format, so that you can get it for your own needs. For example, there is so much data that exists in the world, right? But you just need data that is required for your particular application. For example, when you see an Ethereum block, you should be able to see there is so much data that exists. In one particular Ethereum block, there is MakerDAO transaction. In one particular Ethereum block, there is Uniswap transaction. In one particular Ethereum block, there is Aave transaction. And let's say you are a Uniswap developer and you just need information about Uniswap. How do you get that? That's what is indexing. So basically, indexing information is that all the blockchain has all the data, but you just need information for your own needs. And for that, you need to create a middleware such as subgraphs, so that the smart contract, which has all the data, can get the information that is required to your UI using a middleware, and that middleware is called a subgraph. So in TLDR, a subgraph is basically a middleware which gets the information that exists on the blockchain for your own needs. And that's about it. So basically, this Ethereum blockchain is converted to such simple databases which can be queried via GraphQL APIs. That's what is the graph. In one word, we can also say the graph is actually Google of Web3. In Google, we have Web2 data. There is so much Web2 data that exists. But Google, if we just search ETH Tokyo, it will only give me things that are related to ETH Tokyo. And the reason behind that is there is so much web data, but we just need information for our own needs. And that's where Google indexes all the Web2 data to give you what you need. In the graph as well, there is so much Web3 data. The blockchain data is basically open source. You can do whatever you want with it. You can actually get in whatever information you need. But there is so much data. You just need information, let's say, of all the arbitrage position that is between PancakeSwap and Uniswap. For that, you just need to have your concentrated information. And for that, you will be creating your own subgraphs. So there are two ways to do it. The first way is you create your own indexer, burn the whole dApp, and that's how you create it. That's normally the Web3 way, but not the correct way, all right? There are better ways to actually get the information to your UI, and that is by using this middleware known as a graph, by creating a subgraph so that you can get that information for your own needs. So that's about it. I'll stop talking and let's code together, all right? I'll start from the very basics. We'll first of all deploy a smart contract, and then we will create a subgraph out of that smart contract. Then I will do a transaction on that particular smart contract so that at the end, you can see that that subgraph has indexed that particular smart contract, and you can get the information you need for your smart contract, all right? Let's do it. Let's go to remix.com. If you have your laptop right now, just open it up. And at the end, if you're able to create a subgraph with me, we have some exciting rewards, which are different from bounties. So first of all, I just create a subgraph, let's say an ERC721, which is mintable. Okay, we create this remix subgraph, this smart contract. All right, we have this smart contract. Everybody has seen this ERC721 NFT basic mintable smart contract. I've not created it. I've just gone to Remix and just taken the code template. So the smart contract is with us. Now what we do is just deploy it. Let me check that I'm not on Ethereum mainnet. Otherwise, the workshop is very expensive for me. Okay, I'm on Gorley. And I deploy this smart contract, inject Web3, deploy the smart contract, send transaction. Oh, can somebody send me some Gorley ETH? Send transaction. Come on. Network is busy. Oh my god. Okay, let's do it on Sepolia, which is the new testnet. It's a live demo. Anything can happen. By the way, I wanted to make an announcement right after the end that Sepolia is now on the graph. But now you know I'll be deploying a smart contract on Sepolia and then doing a subgraph on that. So the big news is that the graph is now integrated with Sepolia chain, and you can deploy your smart contracts on Sepolia. And we are going to do it right now. So let's just do it. This is Sepolia testnet. Hopefully this works. If this does not, then I am texting Ethereum Foundation that we need to talk. So, okay, so the smart contract is being deployed. By then, what we do is we go on the Graph Studio. We go on the Graph Studio and basically just log in with our MetaMask. Once we have done that, I'll create a new subgraph and I'll name it Iris, who's sitting right there, my colleague from the graph. And use Sepolia testnet, create a subgraph. So Iris subgraph, which is a Iris NFT, is having this kind of a UI, which is a studio UI, right? And if you are new to the graph, the first thing you have to do is have the libraries installed globally. So npm install -g graph protocol /graph CLI. This is this particular thing that you have to deploy. Once you have that, you will be on terminal, and if you do just graph, you should be able to see all this. If you have this, that means you have all the global libraries that are required. Okay, I hope the transaction is done and we have our smart contract, and we need to actually verify this particular smart contract. Okay, so I flatten the file first of all. This is the smart contract. I flatten the file a little bit, not little bit, totally. Flatten the file and verify. See, single file, 0.18. I hope I'm not very speeding up. If you are coding with me, you should be able to code along. And then I just deploy. I'm not a robot. Verify. Okay, so my smart contract is verified now. I can just go here and be able to check. I'm also going to tell you specifically why I verified my particular smart contract. So basically, with the graph, we created tools so that you don't have to write a subgraph from scratch. Most of the things, most of the events are already catered upon, and you just have to make changes so that your UI needs are fulfilled. All right. So we have just a small TLDR. We had a NFT called as Iris that we deployed, right? And then we deployed it on the Sepolia network, and we actually verified that particular smart contract, and it's verified now. And we also logged into the Subgraph Studio so that now we can do the next things, right? We go on the terminal now, and I create a mkdir known as Iris NFT. You're getting very famous today, Iris. Yeah, I need some money after this, okay? Iris NFT. So we are inside. Now I'll do graph init -- index events so that all the events that exist in a ERC 721 Open Zeppelin smart contract, which is events, all the events that exist, which is transfer, approve, and approve for all. All these events are actually indexed by the subgraph. So basically, subgraphs index events. And in all the smart contracts, we have events so that we can show that to the front end. But there is no way to actually show that. So you create a subgraph so that the events can be indexed, right? So in a ERC 721, we have 3 events: transfer, approve for all. And all these events will be indexed by the subgraph by just this magical command, -- from index, -- from contract, and then I paste the contract address, which is this one. That should be okay. Wait. Graph init. Okay. This is it. This should be able to. So this is a EVM chain. Sepolia is a EVM chain. By the way, the graph is also on Cosmos, Near, and other places. But this is Sepolia is a EVM chain, so we'll just deploy it there. This is Subgraph Studio, and the slug name is Iris. Again, Iris. This is Sepolia, so we'll choose Sepolia. And this is the smart contract. So you see fetching ABI. So basically I've verified my particular smart contract so that the graph command could fetch all the events from the ABI because I verified it, right? It could not fetch the start block. So I'll just take the start block from here. This is the start block. Contract name is contract. And this should be able to just generate a subgraph for us. So an ERC 721 has 3 events, right? And those 3 events will have one subgraph so that we can index all the activities happening on the Iris NFT. How many of you have been able to reach till here? Okay, nobody. Wow. I like it. No problem. You have a lot of time. We can always talk after this workshop as well. But this can be a great introduction to this amazing piece of infrastructure, which is going to be the Google of Web3. We go inside. Okay. So you see, the subgraph is already created, and I'll go in a little depth to explain you what are the parts of a subgraph, right? There is, first of all, a YAML file, which actually defines what's inside the graph, what is inside the subgraph. What that means is that a subgraph has 3 things. The first is you need to define the network where you are deploying it, right? Which is Sepolia. If it is on Goerli, this would be Goerli. If it was on Polygon, it would be Matic. If it was on Gnosis chain, it would be Gnosis chain, so on and so forth. So first of all, you need to define the network. The second thing is you need to define the address you are actually, the smart contract address that you're actually indexing. Then the start block. And then there is this mapping file, right, which will always come up. In that, there are these entities. This is the most interesting part of the subgraph. What are these entities? Are the schemas, basically. You see here, they're already created by the subgraph, by that graph init index event file. So basically, when you have a smart contract, it has events, approve for all, transfer. I showed you that. And according to that, it created schemas for us so that we can, basically query these. So when I actually go on this particular smart contract and hit transfer, that means I have done an event, right? And that needs to be indexed so that at the end the dashboard of your UI can show that this Iris NFT ID 1 was transferred from my address to some other address in your NFT marketplace, for example, right? So basically, you create these schemas so that you can tell that, okay, an approve function was done, a transfer function was done, that will be required for your UI. So the first thing is you always define the schema, right? Here are the schemas with all the things that you want. And the second thing is the events, right? You are actually indexing events and then converting them to schemas. So basically, what happens in Ethereum is that you get events, right? And those events give you data. That data needs to be put in such a way that it can be queried. So basically, these events have raw data, and the mapping file converts those raw data to schemas, right? And that's about a subgraph. You define a subgraph in YAML file, then you have these mapping files so that these events, which have the raw data, can convert the data into schemas which are such good looking. So in the mapping.ts file, you actually define in TypeScript that how do you want to convert the data from the event, which is raw data, to these schemas. That's it. So mapping.ts file is the major file where you define logic. That's it. So this is all about it. We have everything that's required, and now we will. The schema is defined by, like, it's by default. But if you want, let's say, just a Uniswap position. So I'll just delete everything and just have an LP position with ID, transaction from, transaction to, and stuff like that. So whatever you want to query, you just define in schema. And according to that, you set the mapping.ts file, which is the logic for the event, so that the schema can be created. That's it. Great question, by the way. So this is about it. Now we will deploy this subgraph and see the magic of how do you index information in such good formats. We do the graph auth. This is my key. Don't use it, guys. If you do, then you are really bad people. So I do the auth, then I do code gen and graph build. Okay, everything works. And at the end, I just deploy this subgraph in the studio. 0.0.1. So you see, it took 20 minutes for a person to have a smart contract have information via GraphQL APIs. So the subgraph is deployed, and I can just go on the playground, which I cannot see right now. Okay, it's deployed. And just refresh maybe. Yeah, you can see that the subgraph is deployed. I can go on the playground and check. It's empty, right? This is cool. I can just go to transfers and I can still see, let's say, from ID and to, and it's still empty. Wow. So much work and nothing done. Why? Because we have not done any transactions, guys. Come on. You're not paying attention. Let's do a transaction and then I'll show you that that indexing happens in a second. If you don't use a subgraph, you'll have to create a whole indexer, have an event being tracked every time, and pay 100K to AWS. By the way, AWS office is just around that corner, so don't tell them. So this is it. I'll just safe mint an Iris NFT for myself. Is that okay, Iris? Okay. So I just go here and do 1 and just do a safe mint. So I've transferred one NFT into my particular account, and now the transaction, once it is successful, you'll be able to see that the subgraph is able to catch that event, get all the information from, to, ID, and whatever you need, and be able to serve you. Is the transaction successful? Not yet. We need a layer 2 to test nets too, I guess. Who's building one? Okay, the transaction is successful and it took 31 seconds. And now you just go here. Boom. You see the information, right? So as soon as the transaction is successful, you see the indexing happening. And now you have this amazing GraphQL API over here, and you want to query anything around, let's say Iris NFT, or let's say you have Bored Ape Yacht Club NFT, right? And you want to know that who is the topmost holder, right? You want to know who owns this particular ID NFT and at what point in time he bought it, at what point in time Scamp he bought it. You can get everything just by indexing that particular smart contract. So this is the power of creating a subgraph. At the end, you need a subgraph as a middleware between your smart contract and your UI so that you can put in all the information from the smart contract to your UI. So that's the missing piece in creating a full stack decentralized application. This is about it, guys. This is about it. Why do you need the graph? Because there are 15 million blocks in Ethereum, and if you want to create your own indexer, you'll have to scan every particular block and get the information. Who uses the graph? Everybody who has good brains and good devs. So that means Uniswap has a info.uniswap page, right? You all might have seen that. All of you who are billionaires because of crypto have seen it. So who has seen it? Okay, just Marcus maybe. So yeah, so you see this particular info.uniswap page, right? And all the information here is just smart contracts interacting. So you are a user, you go to Uniswap, you interact, you do USDT, USDC swap, and that swap is a smart contract event. That's tracked via Uniswap subgraph, and you get the information here. See, this is a Uniswap subgraph. I'll just expand it a little bit if I can. But yeah, this is a api.thegraph.uniswap. So basically, Uniswap has created a subgraph so that they can get in all the information from their Uniswap smart contract into this UI page. So basically, as I was telling you, the TLDR is if you have a smart contract and you want to create an application which is used by humans, not junky developers, you need to create a UI. And for that, there is a middleware known as subgraphs so that you can use it, right? So this is about it. We also have substreams coming by next month, right? But you can still use it. Basically, indexing events for really fast chains like Polygon and ZK Sync right now coming. It's like a 1 second block, and you need to index everything. And if you have, let's say, 10,000 transactions in every block, then it becomes a little tough to scale it. And with the current subgraph infrastructure, that's why we have substreams. With subgraphs, you can only index events. With substreams, you can also index every granular data. For example, you can index addresses. So basically, you can give your degen score to a particular address by all the interactions it has done on the blockchain, all the transfers it has done on blockchain, everything. There is something known as on-chain reputation, which is becoming very big right now. And you need to compute an address's on-chain reputation based on what it has done. And for that, you can use substreams. It is already coming along. It is a different stack. But I just wanted to introduce this because we have bounties, right? Good bounties. This $1,800 can get you some good meals in Shibuya Crossing, right? I went there yesterday. Good place. So if you create a new subgraph, you can get $1,800, $1,400, or $1,000 based on your capacity and how you developed it. Or what you can do is be a little more intelligent, like me, yeah. So and use the existing subgraph for dashboards. For example, I'll give you an introduction to that as well. For example, so I have a repo in which I have named all the top subgraphs, right? This is the repo. Misari ERC721 Lens protocol subgraph. So if you are using Lens and you want to just use something for your dashboard for a simple hack, let's say you want to find out which Lens address is the biggest scammer or something like that, you can just use the Lens protocol subgraph and use it for creating good dashboards. One good example would be in ETH India, somebody created an arbitrage bot for all the Uniswap subgraphs. So basically what he did is Uniswap is deployed on 3 chains, and let's say USDC ETH price on Polygon is more than it is on Ethereum. So he just queries the subgraph and it shows it on the dashboard that there's an arbitrage opportunity. There's an arbitrage opportunity, right? These kind of innovating things you can do just by using a subgraph already created by Uniswap team or Misari team and do your own thing. So this is about it. This is how you create a subgraph and index information for your UI. That's about it, and this is about me. If you have any questions, I'll be here for 3 days. If I'm not, going out and drinking sake, so you can find me here. And by the way, this was the last thing that I introduced. The first, a news that the graph now indexes Sepolia testnet because graph testnet costs, Goerli testnet costs a lot of money. This is about it. Thank you. Anybody has a subgraph already? Yeah. Yay, awesome. So I'm a good presenter, right? I'm just kidding. I'm just kidding. Sorry, I'm in a hurry to drink sake maybe.
Yeah, I just had like hashtag like participant, and then they said
They use substring.
upstream.
Yeah.
Sorry, I don't know what upstream is.
They build on the graph stack.
Okay.
Yeah.
Okay. They said their strength is like they can fetch the information across the project, like not only one project but all the project, and then is that like something we can do in the future on the graph as well?
So basically,
Yeah. Cool. Hey, folks. I'm Oren. Work at Gnosis. We're the DAO, I guess, that is the steward of Gnosis Chain. The talk today is going to talk kind of briefly just about kind of building on Gnosis Chain, what Gnosis Chain is, but then the bulk of it is going to be about Hashi, which is a new kind of bridge Oracle aggregator. So we'll kind of talk about what that is and why it exists for the bulk of the talk today. But just quickly, kind of talking about Gnosis Chain, kind of why it exists. Gnosis Chain is a kind of community-run chain, formerly known as XDAI. We kind of aim to have this environment that very closely mirrors the mainnet Ethereum environment in terms of both the beacon chain and the execution layer. Big differences are essentially the price for participation. So running a validator on Gnosis Chain requires a 1 GNO deposit, which is a few $100s, as opposed to the kind of 32 ETH, tens of thousands of dollars deposit to run a validator on mainnet Ethereum. So really it's intended to kind of open up at-home staking to a much, much larger audience of users on kind of really low-end hardware with very low stakes, and as a result, we've had a really incredible response from the community. More than 100,000 validators up and running. It's tooling compatible with everything that you already use to write smart contracts for Ethereum mainnet. And the price of transactions is super, super low. The native token on the network is DAI, or kind of DAI bridged over to Gnosis Chain, so XDAI. And yeah, 100K gas is a fraction of a cent. This is really, really great for kind of testing things in production, but also for kind of high throughput applications where you want to have your users be able to kind of participate in some interesting thing on chain that isn't necessarily I don't know, financially dependent, or isn't financially worthwhile necessarily to run on mainnet. So we've seen a lot of really interesting things like games deployed, on-chain games deployed to Gnosis Chain, because they can kind of leverage on-chain mechanics without costing users ridiculous amounts of money just to kind of participate. So we just a couple of links here for kind of playing with Gnosis Chain. You can find the docs at docs.gnosischain.com. Faucets for both mainnet and for the Chiado testnet at gnosisfaucet.com, and then the RPC endpoints for interacting with mainnet, with Gnosis Chain's mainnet, and for Gnosis Chain's Chiado testnet. So I guess what I'd like to do is just encourage folks, if you're building something here at the hackathon, then explore Gnosis Chain as an option for a kind of deployment target. If you are doing something, particularly if you're doing something that would benefit from really low cost transactions and a really stable execution environment, we have a whole bunch of prizes for applications built on and deployed to Gnosis Chain, and we'll talk about them at the end. I'm going to switch gears now, switch topics, and jump into Hashi, which is this hash oracle aggregator. So Hashi is a protocol for cross-chain communication based on this kind of additive security. So multiple inputs, multiple oracles. At its core, it's a hash oracle aggregator. And what I mean by that is it allows you to set up this kind of RIHO, which is this acronym that I'm trying on. I don't know if it'll stick, but it's akin to a RAID. If you've ever set up kind of big storage devices, a redundant array of hash oracles. And the idea here is to distribute trust for bridges kind of on the mechanism level, not put all of your system's trust into one bridge oracle. And the reason for that is that bridges have been responsible for this outrageous amount of loss over the last couple of years. More than $2 billion in 2022 was lost because of bridge exploits. The top 4 of 5 items on the rec.news leaderboard are bridge-related hacks. And I think what this really serves to illustrate is that no bridge implementation, no bridge mechanism is kind of 100% secure. There's always attack surface, and there's always potential for bridge mechanisms to fall over, to kind of break, and to, in doing so, break any systems that are dependent on them. And so Hashi is the system that essentially allows you to not have to trust one bridge mechanism, but rather to distribute trust over a number of different bridges and require that they agree, or require that the threshold of them agree in order to kind of propagate any state change. So the design principles here, we wanted to kind of have standardization at the kind of lowest possible level, the hash for any kind of data or state change that you're wanting to propagate, make it really modular and agnostic to the underlying mechanisms. And then, this idea of this RIHO, redundant array of independent hash oracles, analogous to a RAID. It prioritizes security over latency. So it moves kind of as fast as whatever your slowest oracle is in your kind of threshold of oracles, and then prioritizes kind of robustness and security over execution costs. So it's slower and more expensive than every other bridge mechanism because it requires redundancy, but in doing so you gain a much better security model or much better security assumptions. Essentially what you're relying on is that an exploiter cannot break multiple mechanisms in parallel and convince them all to create the same kind of false output. So even if you are able to break multiple in parallel, it's going to be really, really difficult, kind of near impossible to have them report the same false outcome, is the kind of assumption here with something like Hashi. The goals, diversification on the cross-chain protocol implementations. So we want integrations with kind of multiple different header oracles. What I mean by this is kind of like client, like bridges where you're bringing the header oracle, the header block header from one chain over to another chain so that you can then do things like storage proofs on them. And then also integrations with multiple message passing mechanisms. And this is one reason that we're careful to call it a hash oracle rather than something like a header oracle, because it's really agnostic to what type of information is being passed or what type of information is being aggregated. We're aggregating hashes, and that can be a hash that is a block header. It can be a hash of some message. It could be a hash of some outcome out in the real world. You can kind of use this in any number of different ways. You're just basically creating this mechanism for multiple different oracles to agree, or to require multiple different oracles to agree on a given hash for a given ID in some given context. And what we want to do is allow users to choose what combinations and what thresholds of these combinations their system requires in order to kind of build custom trust assumptions for their system. It's a bit of a messy architectural overview here. I think I have a mouse cursor, cool. So this is kind of drawing a kind of hypothetical example of a token bridge. So we have this token bridge over here on the left side where you would kind of deposit tokens in. This is a little bit out of date, actually. We'd have a message dispatcher contract here that the token bridge would then call to dispatch a message, and that would relay it out then to various different bridge mechanisms. All of these bridge mechanisms are effectively black boxes. They do whatever they do to kind of move information from one network to the other. And then over on the destination network, you have adapters to each of these bridge mechanisms that are then going to kind of feed into Hashi, or Hashi will actually query each of these bridge mechanisms to have them report their canonical hash for a given ID in a given context. And then there's a few extra layers here to enforce specific thresholds and specific sets of adapters. And then eventually a message executor plugging into the other side of the token bridge where a token would be minted. For kind of end users, this is a bunch of redundancy, and so we probably see this being used more by more as a way to kind of create the canonical instance of your token, and then probably leveraging networks like Connect's network, kind of liquidity layers on top of this bridge for relatively lower value and relatively lower value transfers across chain, and the Hashi setup as your way to kind of secure the canonical mint and burn functions for your tokens on either side. So I think it definitely benefits from these kind of faster execution layers added on top of it. So main components here, or main things that we've built and then that we're looking for others to build. Very interested in applications like token bridges, governance bridges, NFT bridges, kind of built on top of this. Very interested in hash oracles, so like mechanisms for passing messages or passing block headers from one chain to another chain. Very interested in Oracle adapters, so for any existing oracles that are out there, adapters for plugging Hashi into those, and interested in things like message dispatching contracts, message executing contracts, and any other novel use cases that you can come up with. I guess we kind of covered that, so we can skip over. And yeah, just links here to a couple of resources. The repos at github.com/gnosis/hashi. I can just drop the whole presentation into the Discord server somewhere, so you can track it down there. And if you want to find out more about Gnosis chain in general, then we've got a bunch of links here as well. If we've got time, I think we do have a bit of time. I can happily answer any questions now, but we can also just go and poke through the code and get a bit of a better feel for how the whole thing works if you guys like. And I can kind of let you drive it a little bit from there. Oh, I should talk about prizes really quickly for Gnosis chain. So there's a handful of prizes here for just applications built on top of Gnosis chain. The kind of top 3 applications built on and kind of deployed on Gnosis chain will get prizes, as well as best project built using Hashi or kind of utilizing Hashi in some way, and best project utilizing Safe in some way. But yeah, let's go play with some code. I guess, does anyone have any questions now? Yeah.
Okay, so I looked at Succinct. Okay. I looked at Succinct's telepathy ZK bridge, and there they can provide the state root, like on Ethereum, and you can't access that from a smart contract on L1, right? Like you only have the block hash, but is it? I don't know how. So when Hashi is being used and aggregating these values, is the assumption that like if the ZK bridge isn't working or someone passed a false proof that the block hash then therefore would be different, or like what values in the block headers can you compare, or is there a way that the AMB can also pass the state root from L1?
Yeah, that's a great question. So I think there's probably two questions bundled in there. Is like what are the other mechanisms that might that you might use for redundancy in this, and then the other kind of question that feels like it's bundled in there is like how do you get from block header to actually proving some data. And so the first question there, yes, you can use the AMB for passing block headers. We built this really crude little header reporter contract here, which is essentially going to allow anyone to report a block header if it's within the range that you can actually get the block headers, which is like 256 blocks into the past. And it's going to push that over the bridge via the AMB's kind of require to pass message function. So we can kind of coerce the AMB into sending block headers over the bridge for us. And then once you have a header, we also have the ability to, thanks to Laurent back here, have the ability to kind of recursively prove historic block headers. So if you want to kind of go back in time further, you can prove the kind of previous block header because it's encoded into the current block header. And you can kind of do that as far back as you like. It's pretty inefficient to go really far back in history, but it works. If you want to go just a few hops back, then it's a probably easier route than kind of coercing the bridge to kind of pass another header. In terms of how you actually extract state from a block header, there's a handful of protocols for doing this. Axiom is one that has built a system for doing ZK proofs on a block header to be able to then validate that some state exists in the block that this block header was produced from. And so, yeah, I think the assumption here with the header Oracle aggregation is that it's going to work in tandem with some way of proving state, something like Axiom. We can also imagine a system here where you might have kind of multiple iterations through Hashi to ultimately kind of get to some state. So you might have Hashi pass, say, the header oracles via various different mechanisms. Hashi pass the block headers via various different mechanisms. Have those mechanisms agree on what the block headers are, and then have another set of Oracle mechanisms that are going to be queried for the state at a given block height, or with the state that is kind of provable from a given block header. And so that you take this kind of second iteration through for each of those oracles based on the header that was reported in the kind of previous iteration. And so, yeah, we're very interested in kind of any additional mechanisms for doing those kind of state proofs or event proofs based on block headers. I think the two systems that I'm aware of for doing this are Axiom, and then I think there's another one called Dendrith. And yeah, I'm sure there's many more out there, but those are the two that we've that have kind of been flagged already as ones that we probably want to have integrations with.
Could you open up this? Okay, if you go back to the header reporter.
Yeah.
And the utils header storage.
Yeah.
Yeah. Yeah.
I don't know why it's not letting me click into it that way, but let's go down to here. So header storage would be on the destination chain, and this is just where we're going to pass in the headers that we've reported from the origin chain.
Right. And so, okay, what contract is on the origin chain?
On the origin chain would be this header reporter here.
Right, which uses the header storage and it calls store block header, which only stores the block hash.
Yes.
Okay, so only the block hash. And then, okay, yeah, I mean, as long as I can use Axiom to make a state proof using a block hash.
What's that?
The header storage is used in the origin chain, right? Not in the destination chain.
How am I mixing it up?
Yeah, I think so.
Oh, right. Yeah. Yeah, so we're using, sorry, you're totally right. So on the origin chain, yeah, here we're calling header storage, store block header, which is, let's open this one up separately, which is, yeah, going to store the block header on the origin chain, and then allow, because it's in storage, allow mechanisms like this header reporter to query it from storage and then relay it over the.
Okay, yeah, I'll look more into Axiom, but if the block hash is enough, because I just looked at telepathy and they're just providing the state route. Yeah.
Yeah.
Cool. Okay, thanks.
Yeah.
So are you guys just thinking about this as a more like an infrastructure tool that we can just check the headers rather than like a messaging like relayer?
I think we see it as both. So it should be able to aggregate really anything that can be represented as a hash. If it kind of maps to this essentially mapping of uint 256 to uint 256 to bytes 32, then it should be able to kind of aggregate it. We have built adapters for execution layer header oracles, execution layer light clients, and then also adapters for sending messages. So we have down here, this Yahoo contract is our message dispatcher. So this is the endpoint that you would use on the origin chain if you wanted to send kind of an arbitrary message across chains. And then on the other side, this Yahoo contract is our message executor. That would be the thing that ultimately calls out to whatever your system is or your contract is if you wanted to execute arbitrary calls.
And what chain is it deployed on right now?
It's not deployed in production anywhere. It's very much still a moving target, very much still in development. And so you guys are kind of getting your hands on it really early, which is great. Hopefully folks here can help shape what it looks like. Cool. I think if there's no more questions, we can probably wrap it up here. I think we've had a pretty decent little dive in. Yeah. All right. Thanks, everyone. Yeah, no worries.
Yeah, I've been actually working on
Oh, right.
Yeah, we're thinking about like
Can I start? Okay, awesome. Hey guys, hi everybody. My name is Fabio. I'm one of the core devs at Push Protocol. And today we're going to be talking about what Push Protocol is, what problem it's solving, how it's solving, and by the end we're going to see different ways of how you can integrate Push Protocol into your mobile app, into your dApp, into your smart contract, or into your wallet. So the first thing is everything starts with a notification, right? So for example, whenever we receive a new email, we always receive a notification alerting us that we have a new email. Or whenever someone makes a transfer money to our bank account, we always receive a notification. So notification has been proving over the years that it definitely increases user experience, but also increases user engagement in your community. The thing is, before push, there was no way for protocols to reach out to the users. Right, so protocols, they expect users to go back to the protocol themselves and fetch the information. For example, when will my ENS domain expire? Well, I have to check it. It's not something that I know by heart. And with a solution like Push Protocol, we can notify you, for example, 1 week before you lose your ENS. Or we can notify you before you lose money on Aave, before your collateral, you lose your collateral. Or we can notify whenever a new streams or superfluid starts. So the solution the problem that we have currently in the Web3 ecosystem is, first of all, for DAOs, as of now, DAOs that have no way to reach out to users to alert them that there is a new governance proposal, right? So for example, I'm part of multiple DAOs. How do I know there's a new governance proposal? Right, I have to go to Discord, I have to go to Twitter, and be very active to see that there are new proposals. For user experience, it would be way better if I receive on my phone a notification alerting, hey, new proposal 0x ABC has started. Do you want to vote? Then you click on notification. Then you can get redirected to Snapshot or any other application to cast your vote. For DeFi, the same thing. For user experience, it's way better to receive a notification before you actually lose the money. Right, I think we all agree on this. And for NFT marketplaces, it's way better UX when you receive a notification whenever someone places a bid on your NFT. I have an NFT, I want to sell it. Whenever someone places a bid, I want to get alerted. I don't want to give my email, I don't want to give any other information, and I don't want to go to the protocol myself to fetch the information. So the solution that Push Protocol is building, it is an open communication layer. That means that anyone can simply go to the network and fetch the notifications and the chat messages. It's all open. Everything is encrypted. All the chat messages are encrypted. Notifications, they can be encrypted and not encrypted. But the end is the communication, the layer is open. Anyone can simply fetch all the chats and notifications. The notifications, they are completely dynamic in two ways. First of all, how you're going to trigger the notification, it is completely up to the developer. Do you want to trigger notification manually? You can go. Do you want to trigger notification using smart contracts? Please go ahead. Do you have subgraphs and then you want to notify your users using subgraphs? You can. Do you want to notify your users on your server? You can. And lastly, the dynamic notifications, they're also dynamic in a sense that the notification itself, they can contain any arbitrary payload. It can contain a governance proposal. It can contain a YouTube video. I can receive a notification with a YouTube video. It can contain a random text. It can contain pretty much anything. There's no restriction of what the notification should look like. And the notifications, they are multi-chain. We're in Ethereum, we're on Polygon, Binance Smart Chain with more chains soon, and also non-EVM chains very soon. It is gasless. So for sending notifications, there's no fee involved, nor for receiving the notifications. And lastly, for me, that's the most important. It is the platform-agnostic delivery part. That means is the user doesn't need to go to the Push Protocol interfaces to fetch the notifications or to fetch the chat messages. Push Protocol is an infrastructure protocol. We build this SDK sort of APIs. We have these nodes, but anyone can import the SDK and have the exact same look and feel that we have in our website or a mobile app in their own wallet, in their own dApp. So in the end, users don't need to know that Push Protocol exists. We're just this infrastructure protocol that send notifications, that send chat messages. But how the users are going to see the messages in a chat message, any front end can simply import the SDK and provide this experience to their community. So push, we have sent over 30 million notifications so far. We have 85,000 different users that have opted to receive the notifications, and we have had over 500 different use cases of notifications. And we have notifications that go from DeFi, DAOs, NFT metaverse, infrastructure, social, media, and services. And I think the difference, so we see that we have a lot of use cases for notifications. And what I like to point out is the notifications that are completely pick and choose. So for example, let's say that I'm a very active user on Lens. I just go to the Lens, I just opt in to receive notifications from Lens, and I will only receive notifications from Lens, nothing else. If at any given moment I want to stop receiving notification from Lens, I just opt out. I sign a message, then I'll not receive notifications anymore from Lens. So the end user has 100% control of what the user wants to get notified, and the user can always opt out. And there's no fees involved into subscribing to this. So as I said, Push Protocol started as a hackathon project in ETHGlobal, like just a normal project. And we have been building for almost 3 years already. And we started with notifications, but now we have chat. And the thing about chat is that chat has been built on top of this notification layer. And why does it matter and why is it important? So first of all, the experience that we have in Web 2 messaging system, we're bringing this into Web 3. That means that whenever I receive a chat message on my phone, on the protocol, I will always receive a notification. So for example, whenever someone messages me on Push Protocol, I receive a push notification on my phone saying John.eth has sent you a message. Then it's like I have this very similar user experience that we have on Telegram, for example. We always receive a lot of notifications on Telegram, so we're replicating this into Push. And of course, in the future, we're going to be able to fine-tune the notifications. So probably I just want to receive a notification for that user, but not for that other user. So then we can fine-tune this. But the goal is the end user will always have the control of what they want to get notified. And here on the left, we have our website. And here is the mobile app. And the idea is the website and the mobile app has been built using our own SDKs. And the idea for this is just showcase that you can have the same UI in your own protocol. Of course, we provide the UI, but the idea is just that you can build exactly this in your own UI. Users don't need to go to Push to fetch all the messages or the notifications. So with chat, wallet chat, I mean, the applications are endless. We're just an infrastructure protocol, and how this system are going to be used is completely up to the developers. Here in the middle, we see that we have group chat. So a couple months back, we announced group chat and token-gated group chat. What that means is now we have a Web3 native way for people to communicate. So for example, I can create a group chat for my DAO. I can create a token-gated group chat. So that means is only people that are allowed to join this group is if they hold a certain amount of my governance token, let's say, and I can create a public group or a private group. So imagine I have my DAO, I have my token, and then I create a group where I say, okay, all the chat messages for this group, it's public, so anyone can see all the chat messages, but only if you hold a certain amount of my governance token, you can send messages. So you can see how nice this can be for DAOs, for online communities. So we're building this framework for better and more transparent communication, so we don't rely on the current chat systems that we have in Web 2. And of course, we have SDKs for both notifications, for both chat, and also for groups as well. We announced yesterday something very nice, which calls Push Video. So it's a new form of communication that we have built on top of Push Chat. So the Push Chat is built on top of notifications, and video is built on top of Push Chat. So we're building these communication Lego blocks that will be on top of each other. And Push Video is literally wallet, FaceTime. I have a wallet, my friend has a wallet, so we can call each other. So here's me calling Madhur, he's a guy that works for us. So literally, yeah. So we're gonna announce the SDK for Push Video probably by next week. And the idea now, protocols or websites or mobile apps can now provide this service, which is wallet video calls. As of now, it's wallet. very, very soon, we're going to announce group video call. So I can not just like create a group. I can call all my friends, but instead of calling their phone numbers, I'm going to call their wallet addresses, and then we can just FaceTime everybody. Here I have 2 videos. So here on the left is just showcase how to log into the mobile application. But as I said, you don't need the mobile app to interact with the protocol. And here on the right, the video is outdated. We changed a lot the UI. But here on the right, we can see how we can start a video call. It changed so much already. I should have updated the video. But see, like we always receive notifications. Whenever someone calls you, you receive a push notification, say, for example, Madur.eth is calling you, like on my phone. And then I can click on the notification, then I can start the video call. And here on the left is how the notifications look like, and also how the chat looks like on the phone. See? Here in the end, we saw how the notifications and then all the chat here. Cool. I can go for some code demos, how to integrate push. Before I go that, does anyone has any questions so far about push? Otherwise, I just go into the code and then we can do the Q&A in the end. Cool. So let me go into the push staging app. So what does the app looks like? You as an end user, let's say I want to start receiving notifications from push. So how does it work? So we have our app here on mainnet. Let me just close everything. Cool. So on push protocol, we have a concept of channels. And the channels is exactly like a YouTube channel. So me as a user, I can subscribe to channels to receive notifications, right? So for example, there is this Shapeshift governance channel. I can just come here, opt in. All I have to do as an end user, just sign a message. And then that's it. Whenever there's a new governance proposal for a Shapeshift, I'll start receiving a notification. And the same go for Lens, Snapshot, MakerDAO, Rect. So the user can completely go and pick and choose what notifications they want to get notified. Notifications, they can come here on your inbox, as we can see here. They can come here on the browser extension as well, see, or on your phone. Let's send a notification on our testnet, because I have a channel created here. So the first step is, if you want to send a notification, the first thing that I have to do is you have to authenticate yourself into the protocol so you can send a notifications. For this, you have to stake around $15 worth of push tokens into the protocol to prove that you're actually a legit person that wants to notify the users. But I have a channel here, call it demo channel. So let's send a notification. So the notification, there are 3 types: broadcast notification, targeted notification, or subset. Broadcast means notify everyone who has subscribed to my channel. Target means notify one wallet, and subset means notify an array of wallets. In this example, let's just notify everybody. And on here on the right, I have just this wallet that I have opt-in to this channel here on the right. So let's send a notification, which means, hey, and my notification message, I'll call it notification message. Then I can add an image to the notification, and I can also add a call to action link, which is whenever the user clicks on your notification, they can get redirected anywhere. But for now, let's call this send just this notification. All I have to do just to sign this payload. It is free, no money involved. And then I have received one notification here. If I come here to my inbox, notifications here. If I come to the browser extension, notifications here. And if I open my phone, my notification is here. If there is any wallet that integrates push, the notification will be everywhere. So notifications dispatched to everybody. We can send also the same notification here, but via code. All the code here is deployed already. It's on GitHub in our push protocol GitHub. So for sending notifications, we have this REST API SDK. To send notification, all I need is the push protocol SDK and the Ethers library because we need to sign messages. So I just import the private key from the wallet that created the channel. So I created a channel with this wallet here. So there are two things. I can get the private key for this wallet, or we can do other thing that I do recommend. For staging, it's fine, but for production, I would add a delegate here, which means another wallet that can send notification on your behalf. I can add my other wallet here and then use the private key from this other wallet. So you don't use your private key for your main wallet. But since this is staging, fake money, there's no problem at all. The channel address here is going to be this address here, the address that created the channel. And the receiver, I'll be notifying this address here, which is this guy here. Just double check, 0xFD6, and this looks about right. This is my notification title, and this is my notification body. I'll change it to this, because why not? And this. Then I'm just calling the SDK, and all these properties here are on the SDK, on the documentation itself. And I'm adding a call to action link. Whenever I click on the notification, I'll be redirected to YouTube. And that's it. So if I come back here, so let me just run this. I send my notification. So if I come here, oh, I have this huge payload here. See, if I refresh here, the notification is here. And if I click on the notification, I go to YouTube. And also here. And also on my phone. Or any front end. We also provide React components because the idea, a lot of protocols ask us like, hey, I want for my users to see the notifications on my own tab. I don't want the users to install anything from push. And that's the end goal. So, and for this, we provide React components for this. So for you, all you have to do is to import this. So have this React component here, which is called notification item. And you can install it from push protocol UI web. You just pass the notification array that you get from here by calling the SDK. You call the SDK, you get the notification array. Then you pass the notification array down to the components that we provide. So if I run this, how does it look like? See? All the notifications that we saw, they're also displayed here. The exact same notification, so if I click here, I also go to YouTube. Nothing changed. See, the idea is just to, it's a platform agnostic. Anyone can display the notifications and chat messages. And also have this button here called opt-in to channel. Because for an end user to receive the notifications, the user has to opt in, to give consent to receive notifications from that protocol. Otherwise, the notifications go to the spam box. And what we say is, users can go to the push protocol tab and opt in to receive notifications. Like I can come here and opt in to receive here. Or you can import, you can use our SDK to create a simple button. Then when you click, you can opt in here on your dApp itself. So let's say your user is filling a form like on your dApp, and then they say, hey, do you want to get notifications about this on your own dApp? Then you can display this opt-in button here. When the user signs in, the user clicks, signs a message. Under the hood, it's push protocol, but the user doesn't need to know that push protocol exists. We have chat as well. So here, how chat looks like. See, so we also have video call here. And from the SDK itself, you can also send messages via SDK using our REST API SDK. So for this, everything is detailed in our docs. So let me just, where the docs are. If you go to docs.push.org, let's go docs.push.org. Here we have developer docs. And if you're a developer, there are two things. If you want to send notifications, you click here. Then you can send notifications from smart contracts manually using the dApp, using the SDK, using the scaffold solution that we provide, using subgraphs, or you can even customize your notification, right? You can add bold text italic, bold and italic, add URL. And if you want to integrate chat, you have here push chat for Web3. Integrating push chat. So here we have some, explanation about the chat SDK, but most of the explanation should be here in push SDK, SDK packages, REST API chat. Here's the documentation for chat where we explain how to send chat messages. And this code here, I copy and paste, and I paste it here. So if I go to push chat, source, no, chat send message, this one, this is how I send a message using the SDK. And we're going to change this a lot, but for now that's it. So first of all, I get my user information from the protocol itself. I decrypt my private key, because whenever you log into push chat, we generate a new encryption keys for the user. We don't sign and encrypt the messages using the wallet private key, because we don't want to touch it. So we generate the only encryption keys that are encrypted using your main Ethereum wallet, or Polygon wallet, or Ethereum Binance Smart Chain wallet. Once you have the decrypted key done, you can just send a message. So if I come back here and I run this, message has been sent, and I send a message to this guy here, 0fd6, which should be this guy here, 0xfd6, which is nice. So if I come here to chat and open here, what did I send? I sent hello Tokyo. Hello Tokyo is here. Let me just change this to this. Yeah, looks about right. Let me send this. Yeah, I receive a notification, and the message is here. That's pretty much an overview. All the different ways how to integrate push, everything is the documentation. We have been working a lot on documentation to make it super easy for developers. And then, yeah, I think that's it. Any questions so far? First of all, thanks so much for the attention. And yeah, thank you.
Hi, thank you for your presentation. I was wondering, for the chat app, is there a way for me to contextualize it? So if I have like a inbox with like 10 different wallets that I'm talking to, how do I know who I'm talking to? Like, if I'm just browsing through it, can I like rename it and be like, oh, that's the guy that minted the same NFT, or how do I?
Yeah, so we have these features just not exposed on the SDK, but we can add sort of a tags. Like, of course, because when you're talking, like you're talking to 0xABCDEFT, and like, I don't know the wallet addresses for all my friends. So then we display ENS names. So if they have ENS, we're gonna see like Peter.eth. So and we have a feature that we can rename these. You can add like my friends or friend one. Then you can rename this. Just not exposed on the SDK yet.
Okay. Okay. So the priority is always ENS first, and if there's no ENS, then it's the wallet address.
Yes.
Okay.
There will be like ENS first and wallet address. Actually, the first one will be like the name that you set it, like friend one. And if there is no friend one, then we display ENS. Then if there is no ENS, we display the raw address.
Okay. And then, is there an option of changing a photo or something?
Not on the SDK yet.
Okay.
Yeah, but we'll have
Thanks.
With the group chats, I don't know whether I missed an example of that, but can you leave a group chat and still get notifications for everything else, or do you have to get notifications from all of the group chat as well as all the other notifications?
Yeah. So you must, when you leave the group chat, then you stop receiving the group chat messages. Then you can no longer read the messages. I don't know if that's your question. Like if I leave my group, then that's it.
But you can't pause the notifications for like a group chat or a single person, or
Sorry, do not understand.
You can't pause or silence the notifications
okay. Yeah,
for
that's
us.
actually a good question. Yeah, not yet. Okay. Not yet. Yeah, that's a very good question. Not yet.
So, if you are planning for the DAO in a group, so you need to have thank you. So, if you're planning for the DAO in a group, so do you need to have the push token, or you can get your own token or some another token?
Right. So no push token at all. Like if you have your own DAO with your own token, or let's say you have a DAO that's token gated by NFT, you can all do this. So when you create a group, on the process of creating a group, there is a section called token gated.
Mhm.
Then you can pass the address of the ERC21 or ERC20. Then you pass there and the number of the tokens there. Then you
Okay.
token gate the group. And then you select if it's a public group, that means all the message content is public. Or if it's an encrypted group, then only the group members can read the messages.
Okay, and you can connect your group to the Discord group too. The Discord private group.
Right. I mean, you cannot fetch, like on this group chat, you cannot fetch messages from Discord. But what I mean, on Discord, you can link to this, like, hey guys, let's try to move this. But I mean, there's no link between Discord and this group chat.
Okay.
We're trying to build an not alternative to Discord, but like, we would want to give another solution for online community to interact, like a more Web3 native way, which is open source, community owned, and that's the idea. We want to provide an alternative, and of course it's up to the community to decide what's best for them, but we just want to provide an alternative and question what we currently have, like, hey, I think we can do things differently, which is open source, community owned, and in the end it's up to the community to decide what's best.
Okay, thank you so much.
Does the user need to install an extension or app so via this protocol?
To receive the notifications.
So when user want to receive this notification, so does user have to install this application or Google extension?
Right. You can. The user can. I think that's the easiest. Like if you install the push mobile app, then you receive actually push notifications on your phone. That's what I personally use for my personal notifications.
Okay.
I just like start my day, see my notifications, my Web3 notifications. That's what I personally use, which is easier. But currently, I would say yes.
Okay, thank you.
That's not the ultimate solution, but that's what we currently have.
Okay, thank you.
Any more questions? Yeah, I think that's it, guys. Thanks a lot. Hey.
My name is Melissa.